Hello, everyone. Our next talk, it's called GitFS, Building a File System in Python. So please welcome Vlad and Manu.
Buenos días a todos. La presentación sería sobre cómo construir un sistema de archivos en Python. Well, don't worry, I'm going to talk in English, so yeah, I thought a lot. Our talk, thank you. Our talk will be GitFS, and we'll share some advice, some experiences in how can we actually build a file system in Python. I'm Emmanuel, and I'm a software engineer at PressLabs.
Hi, I'm Vlad, and I'm also software engineer at PressLabs.
Before we get of the file system, I would like to introduce our company a bit, so you get a what we do and the problems that we encounter. We are a Romanian-based startup, and we do WordPress hosting dedicated for publishers. Our main goals are performance, reliability, and as you can see on the low part of the slide, we encounter numbers along the years. We had 45 million page views on a single site during the day. We also had 6 million page views on a single site in a single hour. In our busiest month, we had 2.2 billion page views. And in the past 12 months, we only had 0.00006 outage, including the maintenance time. Okay, so this is not more. And this neither. Yeah. And we didn't even begin the demo, so. We apologize for this. This was not planned at all. Yeah, like we are on call, both of us, so this is an emergency entry. This is it. Problem solved. Okay. Yeah, this was not planned, but it turns out well. As you can imagine, the business is far from perfect, and one of the problems that we encountered along the years was the conflict between the publishers, namely the site owners, and the developers. So usually the workflow works like this. Someone has a website and a developer, and the developer writes the code, everyone is happy, until the publisher, namely the site owner, tries to change things. And they try to change it even though they don't have the technical know-how. So this is it. We have chaos. They break the site. We don't know what. The publisher starts blaming us. The developers start blaming their publishers and blaming us. So yeah, we have a big pile of chaos. So we thought really hard, how can we fix this problem? And after some thinking, we came up with GitFS. But what is GitFS actually? GitFS is a self-versioning file system based on Git. And once you mount it, you can use it just like a normal file system, but behind the curtains, it will do automatically the versioning part. So from a functional point of view, what it does, it takes this complicated tree structure, which is not really humanly readable, and it transforms it into this. As you can see, we have the root folder, which contains two main folders and history. In the current folder, we have the state of the repository at the moment. So in the current folder, you will find the newest content. In the history folder, we have a folder for each commit. So basically, we take each commit, we take the content from the Git objects, and we display it in a humanly readable way. And in the current folder, you can write, you can change the content, you can view the content. And in the history folder, you can only see the content of the commits. So, yeah, this is it. Simple, right? Now, let's do a demo, and hopefully it will work as planned.
Okay. We have here the remote repository. I'm not using the network, hopefully this time. And here we have the developer clones of the remote repository. And now we're going to mount this file system in mount point. It's very easy. You just pass the remote URL, pass the mount point, some parameters like local repo path, and some timeouts. Okay. Now, in mount point, you're going to see that awesome structure with current and history. In current, you'll have the current state of the repository, which is just a file. And in history, you're going to see a very nice history of that repository grouped by each commit. Now, let's go to the developer side and write some text. Like put 42 in README. We commit them. And just push it. Now, if we go to the GitFS mount point in current and open that file, we're going to see the 42 content text, and in history, the last commit is now. And pretty much that's it. In history, it's a little bit special. You cannot do any write operation because it's read only, neither in the root directory. Okay.
Thank you for that. So yeah, it worked. As you can see, it's easy as 1, 2, 3. It was built entirely in Python. It's open source, so if you find this project interesting, we welcome you to contribute, change it, adapt it to your needs, and maybe we can grow it further from this point on. But how was it actually made? Well, since neither of us had previous experience in building file systems, we started with some research. We jotted some requirements, and after analyzing these requirements, we defined two problems. First of all, how can we handle the Git objects in a very efficient manner, both time-wise and memory-wise? And second of all, how can we implement the file system operations, again, very efficient? For solving the Git objects management problem, we use PyGit2. PyGit2 is a wrapper on top of libgit2, libgit2 being a library written in C, which handles the Git objects directly. So no command line, no time wasted. For implementing the operation, the file system operations, we use FusePy, which again is a wrapper on top of the Fuse C library. And using FusePy, you'll see we have a very elegant way of implementing the file system operations. And now I'm going to let Vlad tell you more details about the intricacies of how GitFS works. Vlad?
Thank you. Okay, to simplify a little bit our job, we introduce a concept called views. Views basically is just a class that implements some syscalls that do some specific logic. For example, for each directory, we created a view for current directory, the current view, for history, the history view, so on and so forth. Between the actual syscall and those views, we introduce a router. And based on some regular expression, when the open, for example, syscall is going to be passed to the router, that router is going to route the syscall to the specific view and execute the proper logic. It's pretty obvious. Django does it. Everybody does it. Now, if I'm going to open a file from 9 months ago, for example, that I'm going to do an open syscall. That open syscall is going to be passed to the router. Router will decide that I need the commit view to do that open. And I will instantiate a new commit view, execute the open, and return the file descriptor. This is our very easy and full diagram we use. We have a main view called view, which inherit from logging, mixing, and operations from views. That view is going to be inherited by read-only view and pass-through view. The read-only view is going to be inherited by history, commit, and index view, because as you can saw earlier, you cannot change the past. So yeah, the current view is going to implement the pass-through view. Basically, the current directory is just a pass-through view with some additional magic for the right operation. Okay. As you can encounter in real life, if you are doing a lot of pushing, pulling, commits, and stuff like that, you get a lot of conflicts eventually. And we did the same. We implemented in our file system a simple push-pull mechanism. And in order to solve those conflicts, we choose to implement a strategy called always except mine. Because for us is one of the safest strategy, but in PyGit 2 you don't have this option, so you need to implement by hand your own strategy. Also, the strategy mechanism is pluggable. If you want to implement or use another strategy, just specify that at the mount point. Okay, let's simulate the conflict. We have a branch, let's call master, with the commit 1, 2, and 3. And on the remote, the developer pushes commit 4, 5, and 6. And our file system on local wrote the commit 7 and 8. In order to always accept the local changes, what we need to do is to get all those 7 and 8 commits and push them after the commits 4, 5, and 6. First of all, we split those local and remote branches in merging remote and merging local branch. We easily can find after that the third commit is the last common commit. And after that, we can find the 7 and 8 are the local changes and local commits that needs to be appended to the merging remote. After that, we just append 7 and 8 to the merging remote and rename the merging remote branch to the local branch. And that's how we solve the conflicts. Now, we have a pretty stable file system. We have a basic pull-push mechanism. We solved the conflicts, but now let's see how it can behave in the real world. For that, we need a really big repository, and we choose WordPress, which has like 70,000 commits. And to do a simple listing on the history view, it took 34 minutes, which is not fun. So as you can imagine, after some profiling, we find our bottlenecks, and we can cache everything. So we implemented 3 layers of cache. The first layer on the bottom, we cache all the Git objects. When we mount the repository at mount point, we read all those Git objects, and we store them in the cache, in the memory. After that, and also invalidate on each new commit that cache. After that, we saw that the router just created a lot of new views, and he didn't reuse them. Each time you wanted to read a new file, he will just create a new view and do the same open and read operations. For that, we implemented a simple all-real cache for all the views, and in the end, we implemented a gitignore cache, and for now we don't support some module. We did that because each time you wanted to write to a file, you needed to check if, okay, in that path where I want to write is in gitignore or in git some module. No. So basically what we did, we just put all the gitignore and git some module content in a big in memory and invalidate that cache on each new commit. After that, after we implement all those 3 layers of cache, we managed to do the actual history listing on the WordPress repository in 3 seconds. So from 34 minutes to 3 seconds is a big improvement. Okay, now for the last part, we needed a smarter upstream synchronization mechanism. Doing just pull, push, and merge is not enough because, for example, you don't want, if you have a big archive and you just unzip it, you don't want to have 1,000 files. You don't want to have 1,000 commits for each file. You just want to have one commit saying, okay, I just wrote 300 or 1,000 files to the disk. In order to obtain such things, we had 4 more components, main components. First, we have the fuse threads, which we don't have control on them. I don't know how many fuse threads fuse will gonna spawn for me or stuff like that. Basically, those are the current history view and other views. We have a commit queue and a sync worker. We use the commit queue to communicate between the fuse threads and the sync worker. The sync worker is gonna do all the syncing, the merging, pull, pushing stuff. And also we have the fetch worker, which is just gonna fetch the certain timeout from the remote. The fetching worker has a special mode called idle mode. For example, if you don't have any activities on your file system for more than a timeout, let's say a day, then it's go to that, it's entered that idle mode, and in idle mode, the time between fetches increase. So for example, if you don't have any activities on your repository or on your file system for more than 1 day, it's gonna fetch only once per week or once per month or so on. We do that to save some resources. Okay, now if our fuse threads are done writing some files, after that some commit jobs are gonna be put to the commit queue, and those jobs are gonna be consumed by the sync worker. The sync worker is gonna batch those jobs and create only one commit. As the commit is created, he wants to push them to the upstream. In order to do that, first we need to merge those commits. In order to merge, we need a clean staging area. To get a clean staging area, we have to lock all the writes and wait until all the writes from the fuse threads are done. We notify the fuse threads, okay, now I need to merge and push, so please don't do any write operation. And also the fetch worker, okay, please stop. I'm going to sync the changes. After the sync process is done, and all the changes are up to the upstream, the sync worker is just notifying the fuse threads and the fetch worker that it's okay, you can now resume your work. The concurrency everywhere. For the final remarks, I will let Manu to say some final words.
Thank you, Vlad. If you want to use GitFS, you can simply install it. We have created an Ubuntu package, and some folks from the community also created one for Fedora and Arch. We also have one for OS X, so if you're a Mac user, you can use GitFS. Okay, and now we want to leave you with some takeaways that we hope will be beneficial for you. First and foremost, you can actually create a file system in Python and use it. You can see we did it. We have been using it for almost a year now, and we had no problems related to the technologies we used. Lots of folks said, okay, you should write it in C or something more fast, but we did it, and as you saw, it works great. Writing a Fuse file system at first is pretty straightforward. You have to implement functions and you're done. But to get the data model right and the operations associated with that model sometimes can be tricky. Again, you saw we had some problems with concurrency. This is the actual model that Vlad spoke about. As you can imagine, it was not the first one that we came up with, and we had lots of problems, and we did a lot of refinements to get here. So this is a word of caution. If sometime in the future you plan to write a file system, you should think really hard about the model. And last but not least, we enjoy working with new shiny tools, programming language. After all, this is a conference about programming language. But sometimes it's good to not forget that our main purpose is making people's lives easier. And we should sometimes focus on creating tools that allow non-technical people to get access to powerful systems. So someone who is not technical could use Git, for example. That's, in our opinion, something pretty awesome. You can find the project here, and we are expecting you. If you think this project is interesting, we are eager to get more contributors, and as we said, to grow it further. It has a lot of use cases that are not yet implemented, but could be. Now, if you have any questions, doubts, please ask. Thank you.
Hello.
Hi.
Can you explain how this helped you solve the first problem that you described with JavaScript?
Yeah.
How is it put to the real world work?
I will answer. We have, basically our clients use SFTP, and they are pretty much familiar with SFTP. So we just mount this file system on a SFTP server, and they can use SFTP, but instead in the background they are using Git file system, this Git file system, and their developers can now use Git, because usually they don't know how to use Git, but the problem is with the publishers.
So in case there's a JavaScript error, you go back to a previous version, or what do you do?
Yeah, you can do that, but it's not automatically. You and do a copy from the history, from the last checkpoint of the repository commit, and then copy the entire directory there.
So I have a question. Great work.
Hello.
Congratulations. So yeah, I'm
okay.
here.
Yeah.
Mhm. So there is a way to limit the number of revisions in the history of in GitFS, so that you cannot. I mean, if you are doing a lot of updates, your storage keeps on certain limits and not grow for too long.
Right now, no, but you can do some tricks here. For example, you can specify that sync timeout a little bit, like to have to do the sync. Basically, that sync timeout somehow is related to how often I do the commit. And for example, I can batch an entire hour of changes and in only one commit. And you can limit that way, but you don't have a hard limit, say, okay, you can do only 1,000 revisions or something like that.
Hello, thanks. Feels like a pretty neat tool. I have actually two short questions. First one, like you shown the Git rebase thingy was it like Git rebase? I mean, it was a slide like 4, 5, 6, and 7, 8 commits.
Yeah, the merging part.
Yeah. So my question is if you can reuse parts of Git actually, or you had to implement it from scratch?
Well, we don't use any Git. We don't use the Git command line tool. So basically, we just did it by hand, and we commit. Here, for example, commit, we needed to merge manually each commit.
Like, and the second short one, like, do you profit from a tree structure or file system? Because it's basically a tree. Thanks.
Yeah, thank you. Can you repeat a little bit the question, because I don't know.
Do you profit from a natural structure from a file system itself?
Not that much right now.
Thanks for your talk. You were saying you are caching a lot of stuff from the Git repository.
Yeah.
So I was wondering, is your memory consumption going up when your Git repository gets really big?
Yeah, but it's not linear or expansionally, because, for example, for WordPress repository, it took only 200 megabytes, I think, 200 or 300 for a very, very, very big repository. Usually in production, we have only like 60 megabytes per repository. So it's pretty, for us, it's pretty low. But yeah, it can get a little bit higher. Even though libgit2 is really, really efficient in that way. And you can tweak a little bit the cache. So for example, the views cache, you can tweak and say, you need to stop at that memory size.
How do you do a specific revert? How do you find that?
Yeah, for now you don't have, it's pretty hard to model that in a file system because, for example, you need a special file, and when you open that file to do a revert, or when I'm writing, you can get a meta file with metadata and say, okay, please revert to that commit. But for now, you only can do that manually, going to the history commit and just move all the commits, all the files, or just the file that you are interested in. But that's a pretty cool feature. Thank you.
Thanks. Do you have a problem with big binary data like images, maybe?
Yeah, we don't actually support that, and we have we have a limit on how much you can write, and this is all tweakable from the options.
And second question about, do you know about GitHub trick for the big tries to move its big files from the Git system to another file system and
Yeah.
keep a link? Do you GitFS keep these links too?
Yeah, for now, no.
Oh.
And I don't think we are going to implement that. But it's a good question, and we can debate on that, because there's a lot of implication to do that.
Okay, thank you for great work.
Thank you.
Instead of using the repository as a backing for a file system, is it possible to use the file system as a view on an already existing repository? So it might just give you a nice way of using a standard file browser and tools to just history of a Git repository you already got.
Yeah, for now, no, because what it does is just clone that repository, but that's a nice idea. That's a nice idea. Usually don't work this way, but it could, yeah, you can do that. For now, I know that you cannot push on the local repository. It needs to be a bare repository to do the actual push, but maybe we can change it a little bit so it can be just a view of your repository. Thank you.
No more questions.
Okay, well,
Thank you.
Hello, everyone. The next talk, it's called What It's Really Like to Build a RESTful APIs with Django. So let's welcome Paul.
Hi, everyone. How's it going? Opportunity for me to be here. This is my first EuroPython that I've ever spoken at. So thank you for taking the time to come and see me. I'll be telling you a little bit about my experiences about building RESTful APIs with Django. I promise you it won't just be me ranting about RESTful APIs. It will be hopefully some gotchas to do with Django REST framework that you might not realize that could probably help you as well. But before I dive in, let me tell you a little bit about myself. My name's Paul. I look very like this emoji. I've been writing software for a few years. I currently work for a company called List, which I'll tell you a little bit about in a second. I consider I might be a bit of a fanatic when it comes to web API development. There's a lot of people who develop really good APIs, and there's a lot of people who develop really bad APIs, and I'm trying to push towards more of the really good API side by advocating good API practices and what it really means to develop an HTTP RESTful service. A couple of years ago, I saw some examples online that were pretty bad. I won't say who they were, but we use it every day. You're probably tweeting about it right now. Oh, gave it away. And I thought, hey, I've got nothing to do this weekend. I'll throw together an API demonstrating good RESTful practices. And I found a data set online to do this with, and it was a Pokemon data set, and I made a Pokemon API. I wanted to demonstrate good RESTful practices. A lot of developers really like Pokemon data, and this got quite popular. It got integrated into DuckDuckGo, and it's been used for a lot of work schemes, teaching people how to use RESTful APIs, and it's just about to tick over 30 million API requests. So that was quite interesting. And then more recently, I developed a Star Wars API, and this was for fun, because I like Star Wars, and the new Star Wars film was coming out, and I'm updating it as the 7 characters and stuff has been revealed. You can check those out online. They're open source, intended to be hopefully good examples of how to develop RESTful services with all these relations. So something a bit more serious now. I work for a company called List. Those of you who don't know, we're a London-based company. We aggregate all of the clothes on the web, so every single piece of clothing you can find on the web is on our platform, and we use a lot of data science magic to find relations between these products, such as their brand and their color and stuff like this, and we let you purchase them all through one website. But we don't just have a website. We also have a mobile application. And this mobile application needs to provide the same type of experience as the web does. This is a very common use case for mobile applications, and it has a mobile API. And when I started working at List, my first task was to look at the existing API, see what was bad about it, and see how we can improve it, because we wanted to start moving towards microservice architecture and the existing API, and translating that into a more modern REST API seemed like a very good way to test the waters with some frameworks that could develop these RESTful API services. And I want to share with you what the old API looked like, and to point out some of the problems I discovered and the reasons why we changed it. So this is a curl request for getting information about a product. We're using this to this endpoint. It's an API or a SOAP style API. Immediately, you've probably noticed something that I noticed straight away as well. Like we just want to read some data here, but we're using this post method. Why are we doing that? Well, we're obviously sending data to the. You can't really do that. You can send body data in a GET request, but you shouldn't really. And this was clearly unsafe from HTTP standards, because we want information, but we don't want to change any state on the server. So why are we using an unsafe method for this? Noticed as well was that there was very little difference between the various endpoints. This is how you get a product. Let me show you how you register a user. Very different use case. Much the same. Like there's almost no difference between the two. In fact, all we're doing is changing the JSON body data that we're sending to it. And then again, I noticed another problem, which was this here. This is the exact same URL. Every single one has the exact same URL. For those of you who are familiar with HTTP, this is bad because you can't really cache it. It's not really addressing a different point. And we also found whenever we tried to endpoints, all we would see in our Sentry logs was there's been an error at this endpoint, and that was it. We couldn't really see exactly what it was without diving in and investigating a bit more. So we came to the conclusion, based off of this, that RPC is not really good for HTTP. In fact, I recommend, this is my personal opinion, that you don't use RPC for HTTP. There's many other protocols that will work with RPC nicely, such as WebSockets. Using HTTP, I think you should be aware of the standards of HTTP and just avoid using RPC stuff. So what should you use instead? Well, we decided that we'd rebuild our this mobile API using Django REST Framework. How many of you here have used Django REST Framework? Wow, all right. So maybe I don't need to give this talk then. OK. For those of you in the audience who aren't aware of Django REST Framework, and there are a few people at work who asked this as well, why should we use Django REST Framework? Well, everyone knows that Django is often called a batteries-included web framework. It gives you lots of stuff for free. Some people argue that it's too bloated and that you'd rather have more granular control over stuff. But you can't argue that Django is so helpful in the way that it gives you user authentication, it handles your HTTP requests, it does all your database interaction for you. And I like to liken Django REST Framework in the exact same way. It's a batteries-included API framework. It gives you everything you need to develop good RESTful API services. But one thing it doesn't really do is it doesn't really encourage you to think about what RESTful services are. But regardless of that, these two go hand in hand really nicely. In fact, I know people who install Django REST Framework and don't even build API services. They want to use various components in the Django REST Framework's library to do various stuff, like swapping out the forms for serializers and things like this. So anyway, what do we learn? I want to share with you the things that we learned. You may disagree. That's cool, because I want to know your opinion on these things. You may agree, or you may learn something new, hopefully, yourself. I think the first thing we realized, that we really realized about this, was that it was a really good opportunity, rebuilding this service, for us to rethink and rebuild and change how we talked about our services. List is a 5-year-old company. We're a London startup. We've been developing very fast, and along that journey, we've collected a lot of technical debt. What we originally had, and the original idea of what List was, in fact, it had a completely different name, isn't what it is now. And the technical debt reflects that in our internal data structure. And that was almost reflected directly in our older RPC API. Like, you could see the internal workings of how List worked through the API, through the method calls you used. We didn't want to do that. We wanted to try and rebuild the service based on what we know now, abstract away from our internal service and just design this really nice API layer on top. So we took this probably radical approach for engineers, because as an engineer, I want to dive in and start writing. I kind of said to myself, no, we need to sit down and we need to think about how we design this service. Think about it from a consumer endpoint. I took the approach of basically writing documentation for an API service that didn't exist yet. Like, how would this look as documentation, completely agnostic of the internal services? Like, my mobile app wants to get users, it wants to follow products, it wants to keep track of them and stuff. So how would I design this? I think there's a big temptation for engineers to dive straight in. But the trade-off spent designing first is so much more beneficial than having to develop an API, iterate it, and then if you put that API online, and then you have to then version it, and versioning is a mess for anyone who does versioning. Designing it first will make sure you're very close to the mark the first time you push that API service out into the real world. Following on from this, like, one of the things we really wanted to think about was what resources we had in our service. Like, what are these things? If you're building an API from the ground up, and you'll find this in the examples, the Swappy and the Poke API things, these are actually, the resources are direct mappings to the models we have. And that's because it's a service that was developed as an API service. You're likely to have a bunch of models internally that aren't what you really want to represent. And I think this is a mistake is that they think resources should be just the modules. And I want to say that that's not true. Your resources should not be exactly what you have internally. They should be more or they should be less. And I want to show you an example right now of how we had this exact problem and how we overcame it. So this is not all of, but this is some of a model that we have internally called the cart. It's a shopping cart. You add items to the cart, you add your binning address and your shipping address, and then you can check out that cart. Straight away, I don't know about you, but I can definitely see a separation of concerns here between various different attributes. We've got shipping information, we've got bidding information, and we've got information. If I exposed this as a resource, I would have all this junk data that I didn't always want to use. It might be handy to be there, but I don't always want it. How can I separate this out and logically develop different resources or sub-resources for this thing? And Django REST Framework comes with something that's really useful for doing this, which is serializers. Sorry, it's the weather is making my mouth go dry, sorry. So serializers, like I said earlier, is something that a lot of people use without even using web APIs in Django REST Framework. They basically work similarly to Django Forms. They do the HTML form component, they do validation, they take some external data, they do some serialization magic, and they map it to some representation. And an example of taking that cart and just exposing the cart attributes. So we have this meta class in our cart serializer that defines a model and a set of attributes that we want to share. You can just have those normal attributes. But one thing I think is really powerful that isn't really spoken about much in the documentation is a serializer method field. Has anyone here used a serializer method field before? No, okay, so this is, I really like this. It basically allows you to stick a method in that serializer and do that at runtime whenever you're requesting it, and you can return back extra data. For instance, the number of items I have in a cart here. So we define the field, we have a method, and the convention it's like get underscore and then the field name, and then you can return whatever you want. So you can compute the total cost of all the items in your cart, or you can compute how many items you have in your cart like this. I wouldn't recommend doing any huge database queries here, just like you shouldn't really do huge database queries in a Dunder repra thing. But for adding those little extra attributes that you might want to use in your resources that you don't want to store in the database, it's super useful in the serializers. So with this, we can take that one cart model and we can logically split it into 3 different resources that we can then map in our URI scheme, and we can address those independently. And you can even take it a step further and rename all the attributes as well. So that's serializers. Keep in mind serializer method fields. They're really, really powerful and really useful to do. We use them all the time at List. About Django REST Framework's routers and our experiences with them. How many people use routers in Django REST Framework? Surprising. I expected less. So routers, for those of you who don't know, they auto-generate your URI configuration for those models you have. It's really great if, again, you've built your service from the ground up and you have direct mappings between models and resources. It's not very useful if you have a slightly bespoke API service. My personal opinion is to just throw them away. You don't need to use routers. Just write your own URL configuration. You've been doing this anyway with Django. You may as well continue being explicit addressing, and you have much greater control over it. Okay, so the last 2 things I want to talk about specifically related to Django REST Framework is permissions and authentication. That, again, we had some experiences with. So permissions differ from authentication by permissions basically says whether or not a user is a staff user or they have permission, they're from the UK, or they can access this view, as opposed to identifying the user, which is what authentication does. I'll get onto authentication in a second. I think, and correct me if I'm wrong, the default, or like I had to change the default in Django when I was messing around on my local dev machine, and I saved it to allow any, and I pushed some endpoints online, and I realized, hang on a minute, like I've got all these like write endpoints where anyone can write stuff. And that's probably not a good idea, especially if you're providing some sort of service that's related to money or something like that. So my advice is to set your default permission class in in your settings to admin only. I mean, this kind of makes sense, but you'll be surprised how many people forget about this, because Django REST Framework will just abstract a lot of this away from you and won't be very explicit about things like that. So if you're using admin only, how do you define the permissions per view? You basically just add this attribute to your class. This is our checkout API view, and then you provide it a tuple of permission classes. And you can write your own, so you can say list admin user or list retailer user or something like this, and you can extend that as long as you want. This is also how you would handle throttling and authentication as well. So if you want to have multiple authentication, again, you just say authentication classes with a tuple of those classes. So that's permissions. Do use admin only. I really recommend it. You'll be surprised how easy it is to throw endpoints online and suddenly have people spamming them and filling your databases with junk data, unless you want that, of course. So authentication. I like making people put their hands up. How many people use token authentication with Django REST Framework? How many people use OAuth 2? Yeah, OK. So token authentication is really good, especially if you want to be user agnostic. If you don't care about users and you just want to give people access to the API, it's a totally cool way of doing things. But if you're providing an API that you need to have much more granular control over, you're going to have to use OAuth 2. Like you get to, it's per user, per application. But Django REST Framework doesn't come with it built in. You have to, or at least it suggests you install something else. It tells you to install this thing called Django OAuth Toolkit. You then obviously throw it in your installed apps, and you change your backend to use this OAuth 2 authentication. Again, I feel like the trade-off here for using OAuth 2, a lot of people don't like using it because it's tricky to set up. If you get used to it, it's really not that tricky. And Django OAuth Toolkit has a really good set of docs on how to provide those tokens. You can have much greater control, and if you're really worried about who's accessing which endpoints, you don't have to basically destroy a token. You can just destroy a user's tokens and keep everyone else let everyone else have access. So do use OAuth. I know it's not nice. And what I think the last thing here is that I really like about Django REST Framework is it obviously makes your request object, the user attribute is the logged in user, so that it does that for you. You get that for free. You get all your authentication. OK, so I've been talking about things related directly to Django REST Framework when developing RESTful APIs. But there's a lot of stuff that isn't really specifically related to Django that I want to cover now that I feel like you need to take into consideration. And I think the big one here is that we have to be aware that HTTP is only giving us so much. Like HTTP is really old. Like I think it's almost older than I am. And we've kind of like duct taped it to work for the web today. Like even things like e-commerce weren't really thought of when we developed HTTP. I think this is the root of all evil when you see bad API services, is that people basically think, hey, you know what, HTTP doesn't give us what I want, so I'm going to like hack it to bits and do whatever I want with it. But it's still a standard. And as everyone in this room who is used to Python and things like PEP8, even the standards aren't enforced, you should probably try and stick to them, because it's a good convention, and that way we can all standardize formats. And I think the same applies to HTTP. I want to give you a real-world example here. So we were trying to think of a way that we could take a shopping cart, the example I gave earlier, and check it out. So check it out means start processing the items we have in this cart, take the user's money, and ship it to them. Now, my immediate thought was, how RESTful can I be about this? A real RESTifarian and basically post like an attribute like cart status equals processing to that point and have it begin. But I felt like that was a little bit implicit, even though it's very RESTful. You're changing an attribute on a cart state, and then you have something in the black box of your API, searching for those states when they change, and then checking them out. I thought that's probably not a good idea, so why don't I make my own HTTP method? And I thought, you know what, that's not really a bad idea, because how many people here use patch, HTTP patch? Yeah, so they brought out patch a few years ago, and it's very much. Some servers still don't support it. Rolling out my own HTTP method is a really stupid idea, and I'm not ready to deal with something like that. So the solution I came up with was to do this. We have a cart resource, and then we have like this sub-resource, which we call checkout. Post, so we're performing an unsafe operation on the server, but it's very explicit what I'm trying to do here. I'm trying to check out this cart. It's very different from updating the attributes on the cart. And in this particular case, it's a very dangerous thing because I'm handling people. So I wanted to move it away from the rest of the API and have it in its own isolated area. I feel a little bit guilty doing this because I am quite strict on like what makes a good RESTful API, but I think sometimes you have to accept that you're going to have to bend the rules a little bit. You can still stick to HTTP standards, but eventually you're going to have to change something until someone comes up with HTTP 3.0 in 20 years or something like that. And then we can actually start doing e-commerce slightly better online. Let's talk about asynchronicity with HTTP services. You're probably thinking, this is a bad idea, just use WebSockets, and I probably agree with you. But if you are trying to stick with an HTTP-only service, and you want to handle asynchronous actions, such as the checkout method, it's fantastic. This thing gave me so much trouble. We dump all these checkouts into a queue. And these queues can take an indeterminate amount of time. It could take seconds. It could take hours. We don't have a HTTP connection open for that long, waiting for a response. So how do we deal with this? And we can use something called webhooks. But I don't really like to use that word when I introduce the subject because it's a very vague term. You have to really know what it means. And I want to sort of show, we ended up using this asynchronous callback framework with HTTP here. I couldn't find anything good for Django that does this nicely. There's some stuff, but it's just not really being developed. So we rolled our own. We send a callback URL along when we post this cart, when we're checking it out. We can also send an iOS token or an APNS token for iOS. And we immediately get back a 202 accepted response. This is a really short turnaround, and we close that connection. We obviously want to keep this stateless. 202 accept sounds like what it means, like we've accepted this response, there's nothing wrong with it. We've accepted this request, sorry, there's nothing wrong with it. We're going to go ahead and we're going to start processing that for you. When that's finished and processed, we then either push out a push notification to that iOS app, so you get this lovely little pop-up in-app, and it's like it's friendly and it's user experience fun, stuff like that. You get an email, and you also, if we have a callback URL, we then actually send it data. We post data to it saying that checkout that you just wanted to we finished it, or there's something wrong, your billing details are wrong, or we can't ship to Mars, or something silly like that. And yeah, so this is a really good way of closing those connections and handling HTTP asynchronously and nicely. So I just want to wrap up by talking about documentation. Earlier, I mentioned when you're designing your APIs, you should try and design your first draft almost like it's docs. The reason for this is because that documentation, which should be a living document that you're updating and changing as you're going, it becomes a really good basis for acceptance testing, and it becomes a really good basis for your monitoring services as well. And it also basically means you've almost got documentation for free after that. If you're not documenting API, I don't care if it's the best API in the world, it's a bad API. You really need to make sure you document the service well. Even if the person sits opposite you, like with me, the people using the service that I built, they sit directly opposite me, but they're always asking, how do I use it? So we've been writing documentation explicitly stating how they do everything. And the two things we've found that help the most with documentation, and I implore you to have, is a copy and pastable curl example of every endpoint you have, so that I can drop it in a terminal and I can do something with it and I can see it working. Most people here can figure out what curl is in their language of choice, like they can translate that to Objective-C or Python or Ruby or whatever. And the second thing you really should consider having is a getting started guide. You'll be surprised how many internal company docs don't even have these how do I get my authentication tokens guides. You have to go and find someone with the knowledge in their head. And obviously, if they're the bus factor of one and they're gone, you can no longer use that service because they're under a lorry. So having a step-by-step guide on how to get authentication tokens and curl examples is definitely something you should have. I really, really implore you to do that. So to wrap things up, kind of like my takeaways here, there is so much cool stuff available in Django REST Framework. I disagree about the whole bloated argument. It just does so much for you that it's worth the trade-off, even if you're only using one component of it, like serializers or its testing classes. Before you dive into the code, please resist the urge to do that and actually think about how this is going to work. Like, think about it from a consumer point of view. Imagine there's an API that's already existed. How do you use this? And take that opportunity. Redesign how your service is. Talk to people in your business, like how do you want to use this service and how can it benefit you? If you really need to bend the rules a little bit to work with RESTful style, that's totally cool, so long as you document it exceptionally well. As long as it's very explicit and clear about what this is doing, that's totally fine in my opinion. And finally, if you are using HTTP, please try and avoid using RPC because it doesn't map very nicely to it. So, thank you very much for your time. My name is Paul Hallett. Again, I'm on Twitter. If you want to rant with me about APIs or tell me I'm wrong, you'll be able to find me. There isn't much time left, and I don't really like taking questions in this kind of environment because it's not really conducive to knowledge sharing. So I'm going to be outside. So if you want to come and ask me any questions, we can have a chat about it out there. Other than that, thank you very much. Is that all right?
I think we have some similar. Hello, everyone. Our next talk, it's called Python Infamous Go. And so welcome, Laurie.
Thank you. Is the mic working? Yep. OK, good. So I'm Larry Hastings, and this is Python's infamous GIL. I'm going to talk about the GIL. I'm going to talk about what it is, what problem it's trying to solve, how it solves it, what the ramifications of those choices are, what its history is like, and what its future is like. And I originally proposed this talk at it being a bit of more of an advanced level, and the way that I wrote it, it's really kind of friendly for beginners too, so don't get scared. So let's wind the clock back to 1992. Python's about 2 years old. Still young and fresh and evolving rapidly. It was mostly used around CWI, where Guido was working, but it had also been released on the internet. There was a new technology out there in operating systems, something called multi-threading. This isn't something that people had dealt with very much to date. It was seen on Mach. I think it was available on SunOS. Most operating systems didn't support it. It was in the betas for the new operating system from Microsoft called Windows NT. But this multi-threading, what it was is it was kind of like multi-process, except that it was all in one process. You had multiple threads of execution happening inside of the same process while the same shared state. People wanted to try experimenting with threads in Python, but you couldn't just start adding threads and expect everything to work. There was going to be a problem. The first problem is so a global in C is kind of like a module attribute in Python. It's something, there's only one of them, and everybody knows where it is. If you have multiples of these threads and are all trying to talk to the same global variable, you're probably going to have problems. As an example, globals in Python, there's a pointer to the current executing frame object. And there's one of them, and it's a global variable, and everybody can see it. If multiple people tried to play with the frame object pointer, you'd have trouble. An even worse problem, though, is so Python uses a technique called reference counting to manage the lifetimes of objects, to destroy them when nobody's interested in them anymore. And I'm going to do a deep dive right now about what reference counting is, how it works, and what the ramifications are of reference counting is with multiple. So, reference counting. Inside of the Python interpreter at runtime, every single Python object starts with these two fields. The second one is the type of the object, and the first one is what's called the reference count. This is an integer, and this integer tells you how many people are interested in this object right now, how many people are holding references. So if the reference count is 3, that means that there are 3 pointers pointing at this object. And what you do with this reference count is, every time you take a new reference to the object, you increment that number. And every time you are no longer interested in the object, you decrement that number. So you incref and decref. When the object count, reference count drops to 0, nobody's interested in this object anymore, and so you should destroy it. You call the dunderdel if it's got a dunderdel, and you release the memory, either giving it back to the operating system or recycling it and using it for another object. So in C, there are these things called macros. This is kind of like a subroutine call, but it's actually done as more of a textual substitution. So incref and decref are how you manage the reference count inside of C. These are what they look like today. The ones in 1992 looked much the same. So let's look at what happens if we have 2 threads that are trying to deal with the reference count at the same time. I'm going to show it to you in exhaustive detail, and I'm going to show it to you both when it works and when it fails. Now, thread 1 and thread 2 both have references to this object in the center, and they're both going to drop their references, so they're both calling decref. Let's turn the decref into the underlying C, but even this isn't deep enough. We actually have to go one level deeper and look at the assembly language that this was compiled into by the C compiler. This is actually just pseudo-assembly language, but this is very accurate to what's actually going on. So let's say that the object has a reference count of 3. Thread 1 loads that reference count into something called AX. AX is a register on the CPU, and you can think of it as a variable. Each thread has its own set of registers, effectively, so they get swapped around. So thread 1 loads the value of 3 into AX. It then decrements it, so now it's 2, and it stores it back into the object. The reference count and the object is now 2. Thread 2 comes along, does the same thing, loads it into AX, decrements it, and stores it. And now the reference count on the object is 1. This worked. We have 2 threads, they both dropped their references, the reference count on the object dropped to 1. Now let's do it again, but this time we're going to do those things in a different order. Thread 1 loads it, and now it does it 3. Thread 2 does it at the same time, almost at exactly the same time as thread 1 does it, and it also sees 3. Thread 1 decrements, so does thread 2. Thread 1 stores, so does 2. But thread 2 and thread 1 both wrote the same value. Both threads dropped their references. It should have dropped from 3 to 1, but it only drops from 3 to 2. This is a bug. This is what's called a race condition. Both of the threads were racing along, and they kind of stepped on each other's feet. Now, you have the inverse problem with incref. If you have two threads that both incref the object at the same time, then the reference count can be 1 too small. The problem here, you get different results depending on which it is. If you have the reference count too large, then what happens is if everybody releases their references to the object, the reference count is still positive, it's 1 or more, and nobody has references to the object, so nobody's ever going to clean it up. So now this is leaked memory, and if there is a finalizer and it has resources, those finalized resources never get finalized, and you're leaking resources too. The inverse problem is much worse. If the reference count is too low, then let's say that it's 2 and there are 3 people who have references to it. The first guy drops and it drops to 1. The second guy drops and it drops to 0, and it goes away. We now clean up the object. We release the memory either back to the operating system or reuse it. But there's still one guy who has a reference to this memory. He thinks it's a valid object. What's he going to see? If the memory's been given back to the operating system, the program will just crash. If it's been recycled to use for another object, he's going to see garbage values. He might crash. He might compute some inaccurate result. Who knows? But this is a really nasty bug, and it's really hard to debug. So getting your reference count numbers are wrong is really painful. So we want to prevent this from happening if we're going to make Python multi-threaded. So the first approach that one might think of would be to add locks around everything. A lock is something you use in multi-threaded programming to prevent multiple people from using something at the same time. You can think of it as kind of like being a bouncer. There's a bouncer standing at the bar, and he only lets one person inside at a time. So the first person comes along, he says, go on in. The second person comes along, and they have to wait until the first person comes back out, and then the bouncer says, okay, now you can go. So we could throw a lock around every single global thing. We could say, in order to use the frame pointer, you have to be holding this lock. In order to be or maybe we could do it for groups of things together. We could group together all the stuff that's for the runtime currently executing stack frame. And we also would need at least one, maybe more than one lock for reference counts. The problem with using multiple locks like this is you have a special kind of race condition called a deadlock. So let's say that we have 2 threads here. This is an example of a deadlock. And thread 1 and thread 2 are going to try and use those locks. The problem is that they grab them in the opposite order. So thread 1 grabs A, then B. Thread 2 grabs B, then A. And the problem is if you execute them in this order, thread A, and that works fine. Thread 2, that works fine. Now thread keeps going. Thread 1 keeps going and tries to grab block B. Nope, it has to wait. Thread 2 tries to grab block A. Nope, has to wait. These 2 threads are now deadlocked. They will never make progress. And if any other thread comes along and says, I want thread A or lock B, it's going to get stuck too. This is a deadlock. This is another painful thing in multi-threaded programming. You don't want to have this problem. So Guido very carefully, in 1992, very clever, that's it. That is the interpreter lock. Since it's global to the whole Python running process, we call it the global interpreter lock, or the GIL for short. That's what it looked like in 1992. Almost 2 years to the date, by the way, since the Python repository was created. If you want to see what it looks like today in Python 2.7, that's it. It really hasn't changed in whatever this is, 23 years. In Python 2.7 anyway, we'll get into that in a minute. Now, in order to interact with the Python interpreter to do anything, you have to be holding the interpreter lock. In order to interact with an object, in order to run Python bytecodes through the interpreter, you have to hold the GIL, which is both good and bad. So let's talk about the good. This is simple. Simple is easy to get right. Because it's part of the Python C API, extension modules have to hold the GIL in order to interact with the Python interpreter. Made it a very simple rule, and it was very easy for extension authors to get right. This led to people writing lots of extension modules for Python. The story of the Python GIL is really the story of the success of Python. People who hate the GIL don't understand Python's history. Without Python would not have been as successful as it is today. So, also, because you only had one GIL, you can't have a deadlock because there aren't 2 locks that you have to deal with. Now, if you have IO-bound code, if you have multiple threads and they're all blocking on IO, then this also just works magically. Your program runs as fast as it can. If your program is CPU bound, then your program is effectively single-threaded because, again, only one thread can hold the GIL, or only one thread can be interacting with the Python interpreter. So if you have 3 threads that all want to be running code, only one of them can do it at a time. Therefore, you're effectively single-threaded. We're going to talk about that. That's why people don't like the GIL. Now about this, the reason that it works magically for IO-bound code, there's another one of these macros. It's 2 of them, actually, PyBegin allow threads and PyEnd allow threads. So Guido realized, if you're going to go off and do some long computation in C, if you're going to be calculating some long Fibonacci number, or you're going to be blocking on I/O or something, you're not going to be interacting with the Python interpreter, you might as well drop the GIL. Let somebody else use it for a while, and then you can go and grab it again when you need it. So that's what these macros do. And these are, again, very easy to use. You can use them used all over in the Python source code. Anytime you're going to do something that might take a while, drop the GIL, do your thing, grab it again. So what's examples of these things? If you're going to go to sleep, obviously you don't need the GIL. If you're going to read or write from a file handle, you can drop the GIL. If you're going to socket, you can definitely drop the GIL, because that could take who knows how long. But sharing the GIL in CPU-bound code, that doesn't work. Now, the GIL didn't change, like I said, for a very long time. In 2009, David Beasley gave a presentation at a Chicago area Python user group. David Beasley is a computer researcher. He loves Python, and he's very interested in the GIL, so he's played with it a lot. And he discovered some things that were kind of awful. So first of all, when you have multiple threads that are trying to use the GIL, there's an internal thing in Python. I should have put it on the screen. It's not there. It's called the sys.set check interval and sys.get check interval. This is a number that's set to 100. And what that says is, every 100 bytecodes, the currently running thread is supposed to say, OK, let somebody else have a turn. That doesn't work. Here is a diagram showing 2 threads running at the same time. They're both CPU bound. They both want to use the GIL all the time they can. And you can see that little arrow there. That's 66,000 ticks. This is 667 times longer than it was ever supposed to be. This checkerboard was supposed to be like tiny little slices, and they're running for a very long time. So people aren't releasing the GIL when they're supposed to. But it gets worse. If you have 2 threads, and one of them is I/O bound and the other one is CPU bound, what you want is the I/O bound thread doesn't run for very often, and it doesn't run for very long. It does a little work, and then it waits on a socket. And then it does a little more work, and it waits on a socket. You want to let that thing run whenever it's ready to run. So if you have a CPU bound thread and an I/O bound thread in the same process, you want to prefer the I/O. Here, the CPU bound thread is getting all the time, and the I/O bound thread never gets to run. This is what's called priority inversion in the world of operating system schedulers. And Python had it in a really bad way. The problem is this code that's supposed to be releasing the GIL and letting other people have a chance to run. So this is it. What it does is this pythread state swap thing, that's this macro that we saw before, this allow begin thread, or what it was called, end thread and begin thread. So this is releasing the GIL here. Then we say, other threads can run now. And then the immediate next thing we do is acquire the lock. So what was really happening is if we have 2 threads, and this one has the GIL right now, and this one wants it, he's saying, you can have the GIL. Oh, I take it back. You can have the GIL. Oh, I take it back. This guy never gets a chance to get the GIL. And it's worse if he has a chance, and if he's I/O bound thread, he's never got a chance. So this, by the way, is still what Python 2.7 is like. This is Python 2.7. It was fixed in Python 3 in 2009 by Antoine Petrou. He wrote what's called the new GIL. And only a minor change to the GIL. It added a new variable called GIL drop request, which is something called the condition variable. In effect, this is a flag. If the second guy is trying to grab the GIL and he's not getting it, sets this flag and says, look, there's somebody waiting. You really have to give it up. And then the first guy who releases it, he releases it. This flag is set and he says, oh, I really have to back off and let other people have a chance. So with this change in place, the really bad behavior that David Beasley was saying is fixed. There are still funny conditions that you can arrive at where you can still starve threads for CPU time and never getting the GIL, but it's a lot now. And to fix those really funny conditions, it would require making the GIL a lot more complicated. And what we're really talking about at this point is writing a scheduler. And I only know a little bit, it was very complicated. And the more fair you want to make it, the harder problem it becomes. And this is really kind of a rat hole that we don't want to go down in the Python source tree. So the plan was we were going to try a guild this way and see if it worked okay. And basically, it's been fine, and we just want to leave it alone. So this is the guild that's in 3 and above, I think. Now, meanwhile, while we haven't been paying attention to all this, the world has kind of changed around us. So I remind you, Python itself was written in 1990, originally created in 1990, and multi-threading was added in 92, I think. Now, you didn't see multiple cores, you didn't see multiple CPUs in a computer very often back then. You'd have to actually go and get a second CPU and have both of them on the motherboard. I had a computer like that in 1995, 96. I had 2 Pentium 133s in one single computer, but I was kind of a weirdo. You didn't really see it prevalent until you had multiple cores on a single CPU. You didn't see that until about 2005. That's when server CPUs and desktop CPUs, and actually the CPUs used in game consoles for the home, those all went multi-core in 2005. And that's when we started really seeing a lot of in multi-core use in programming. Laptops themselves went multi-core in 2007. Tablets and phones and systems on a chip that are embedded in very small projects, those all went multi-core in about 2011. Eyeglasses in 2013. Watches went multi-core in 2014. Ladies and gentlemen, eyeglasses and wristwatches are now multi-core. We live in a very multi-core world, and we still don't have a solution for running Python on multiple cores simultaneously. Now, Guido has talked about this. He wrote a blog post back in 2007. He said, by the way, Python 3K, that's the old name for Python 3. He said, I'd welcome a set of patches in the Py 3K only if the performance for a single-threaded program and for a multi-threaded but I/O-bound program does not decrease. This is a tall order. It's been almost 8 years. Nobody. We're not sure how to do it. People have tried in the past. There was a famous patch back in the Python 1.4 days called the free threading patch. What it did, it didn't require changing the C API, which is good. It took all of those global variables, like the pointer to the current frame, it stuck them all into one single dict, or a struct, excuse me, a C struct, which is roughly equivalent to a Python class. So now you could have more than one of them. So he created one per thread, and now they didn't stomp on each other. And then he added a single lock, a mutual exclusion lock, around incref and decref. So you had to be holding this lock in order to do an incref or a decref. And so you would grab it, do your plus or minus, and release it. This added so much overhead that performance is terrible. It was between 4 and 7 times slower. And this is results based on David Beasley reviving this patch like 10 years later. A couple of years ago, a guy named Antoine Petrou, who's around the conference today, he tried something using atomic test and set. So modern computers actually have a machine language instruction that is a single instruction that says, subtract 1 from this value over here. So you remember those 3 instructions, load, decrement, and store. It combines those into a single instruction, which it guarantees will happen atomically, and you'll never have any problems of races. So that's good. It doesn't require any API changes, which is also good, but it makes it 30% slower. So again, it doesn't meet the bar that Guido was talking about. Now here's something to consider. There are 4 big Python interpreters in the world. There's CPython, and then there's everybody else. CPython has a GIL, everybody else doesn't. CPython uses reference counting, everybody else doesn't. What do the other people use? They use something called garbage collection, mark and sweep garbage collection. You can, if you have garbage collection, you don't need the GIL nearly as much. It's very easy to say, okay, we can get around it. PyPy actually has a little bit of a GIL that they just use during garbage collection cycles. They say it wouldn't be that, it'd be kind of a pain to get rid of it, but it's not impossible. It's impossible to get rid of the GIL as long as we're using reference counting. So people say, we should go to garbage collection with Python. Okay? The problem with that is that that changes the API. We change, in order to talk to the Python interpreter, you call the C API. In order to deal with objects in the C API, you have to understand Python's memory management approach. So external programmers have to know incref and decref. If we got rid of those and changed to garbage collection, that changes the API. That breaks every extension out there. There are a lot of extensions for Python. We don't want to break them. So I'm not sure that we can do this. Would it be any slower? Would it be faster? Conventional wisdom, or at least told to me by Michael Ford, is that garbage collection and reference counting are roughly the same, but we wouldn't actually know until we did it. And it would be a lot of work, and nobody has been gutsy enough to try. Here's something else to consider, though. So all of the major languages that have come out since Python was invented, like the JVM for Java and the CLR for C#, Rust and Go, all these things are using garbage collection. Also, all of them don't have C APIs. PyPy doesn't have a C API either. Now, why is that? Well, the obvious reason is that these languages are generally considered about as fast as C. So the reason for writing a C extension to speed things up, you don't need it. They all have the ability to call out into a C library. And so maybe they think that, well, you just don't need it. You can call out to a C library, and you don't need the optimization of an extension, so we don't need the C API. But another thing to consider is that, like I've just said, having a C API means exposing your memory management model to the world, which means that now your hands are tied. If you change that memory management model, you break everybody's C extensions. If they don't expose the memory management model to the world, they are now free to change it internally. PyPy started out with a simple mark and sweep, I think. He can correct me. It started out with simple mark and sweep, and over time it became generational and became an incremental collector. And Armin told me that the change to incremental wouldn't have broken anybody's code. The change to generational probably would have. If they had exposed the C API, they would have been free to make those changes, and PyPy wouldn't have the better memory manager that it does. So if CPython switched to garbage collection, again, this would break every C API out there, and then if we made improvements to it later, we might break everybody again. So in my opinion, I think that if we went the route of trying to change to a garbage collection, we should probably give up on having a C API. Which again, we break everybody's C extensions and we don't fix them again. Instead, we say, rewrite your extensions in Python and use CFFI, which by the way is wonderful because then that lets you run on PyPy, and also Jython and IronPython are talking about CFFI support. So this would mean that your extensions were now portable across Python implementations. I think for political reasons, the only thing that we could really talk about is atomic test and set. And even with a 30% speed loss, I think that the pressure for supporting multi-core is going to get big enough that we're really going to have to look at doing this. That's it. So the coffee break has started. So if you're jonesing for a cup of coffee, you can take off. If you have questions, I'm happy to answer questions for a couple minutes until they kick me out. Somebody is holding up their hand up on the aisle in the center. Yeah.
First of all, thank you very much for this awesome talk. So you say garbage collector is C extensions, but what if somehow mark the code as pure Python code that doesn't interact with the C extensions, and there you can, with those objects, you can do garbage collection, and somehow mark that the code that interacts with the C extensions, and there use GIL or atomic increments, decrements, because like there is a lot of pure Python code out there.
Okay.
That, why not use garbage collector in there?
Python, code that runs in Python doesn't care about whether it has a garbage collector or whether it's reference counted. So I kind of didn't understand your question. Maybe you're going to have to clarify it. But I will point out to you that CPython has reference counting, and all the other Python implementations use garbage collection, and your code still runs either way. So it doesn't matter. So I'm not sure I'm answering your question.
I mean, imagine a Python program that doesn't interact with any C extensions. What prevents having a garbage collector there?
Nothing. You can run it today, because you can run it under Jython or IronPython or PyPy, and those have pure garbage collection. They don't have...
No, I mean, why not implement it within CPython?
I'm sorry?
Why not to implement it within CPython?
Why not implement it in CPython? Because that breaks all of the C extensions, and people use C extensions all the time.
Yeah.
And to provide a data point, can I interrupt, Larry?
Sure.
So Resolver Systems at one point implemented something called Ironclad, which was an implementation of the Python C API for IronPython. And IronPython doesn't have a GIL and it doesn't use reference counting, but we maintain binary compatibility with the existing binaries, because this was for Windows and people basically can't compile their own extensions there. And so what you have with those existing binaries is you have C objects, effectively Python objects implemented in C that expects to use referencing. And so we had a hybrid system. Objects that were returned from the C extension, we artificially inflated their reference counting by 1 so that the macros compiled into the binaries would never be triggered by getting down to 0. And then we had a proxy object that if garbage collection was entered for this object, then we would trigger reference counting for the, we would decrement the reference count. Technically, we had a leak, though, because if you pass in references to Python objects to the C extension could keep references to those alive. And essentially what Larry is saying is that if you move to like mark and sweep for the main Python C interpreter, those C objects are opaque to the garbage collector. It can't know what internal references you have. That's kind of what you're saying, isn't it, Larry?
Yeah.
Unless you change the API.
So Python actually supports garbage collection. CPython does support garbage collection, but it's only used in a very small way. It's used to break reference count cycles, and most objects don't bother to implement it. So if you had an object you created in the C extension, it might have references to other objects, and you have no visibility inside of it. The world that he lived in with IronPython was a little different, where they were running inside of the CLR, and the CLR knows everything. In the C runtime environment, we really know nothing about the memory that's been allocated.
I mean, in practice, we had no memory leaks that we could find from objects, from C extensions keeping other objects alive or those objects dying when the C extension. But that was only in practice. It seemed like it worked. So you kind of want your system to be theoretically tight, not just working by accident most of the time.
Yes.
The answer to my question is no, but is it possible that two threads think that the GIL is free? They claim it, and then something strange happens?
The lock objects are provided by the operating system, and they're very good. So one thread grabs the lock, and the operating system does a very good job of only allowing one person to have it at a time. Yeah, it's not fast. It depends on the operating system, actually. Like Linux has what they call the futex, and I think Python may use futexes on Linux, so that is very fast. It depends on the operating system. Some locks are actually pretty slow. But we live in 2015. I think all of them are fast these days. Yeah.
Hi. What do you think is the feasibility of having a CPython interpreter that breaks the C API and you use it when the extensions have caught up?
So you're talking about forking the Python interpreter and going to garbage collection for that? Yes, certainly you wouldn't. That's possible. I'll point out to you that we're in 2015 and CPython 3.0 came out in, what, 2008? And there are a lot of C extensions that still haven't caught up here. So people are very slow to adjust to changes to the C API. And I worry that the change to garbage collection would be even worse than the change from Python 2 to Python 3. So I'm not optimistic about making a fork of Python that has pure garbage collection and everyone saying, oh, I want to switch over to that, and it really taking. I mean, at some point, you make so many changes it isn't recognizable Python anymore, and you might as well switch to PyPy, because those guys have been doing it for a long time, and it kind of works. Mostly. Okay, I think everybody wants to go to coffee. Thank you.
Hello, everyone. Our next is called The Guild is Dead, PyPy STM. So let's welcome Armin.
Thank you. So the GIL is dead, or that's what I pretend. What do I mean by this sentence exactly? The GIL, the Global Interpreter Lock, it's, well, if you have been at the previous talk in this very room, you know already exactly what the Global Interpreter Lock is. I assume a lot of you do. If you don't, well, it is simply a lock that in the CPython or PyPy implementation of Python, it is one global lock that needs to be acquired in order to run any Python code. So Python code can run only if it has a lock, which means if you are writing a Python program using multiple threads, and all these threads are trying to do some CPU-intensive computations, then actually only one of them will run at a time. This is the basic story. And this has been the case, well, since forever, since '92 in CPython and forever in PyPy. So here I'm talking about PyPy. What is PyPy? PyPy is an alternative implementation to the Python language. It was started 10 years ago. It has better performance most of the time because it has, well, just-in-time compiler built in. Try it, it's great. Now, STM means software transactional memory. What do I mean by that? Please see the part 2 of my talk. And now PyPy STM is an alternative to PyPy. So it means you need to use another version of PyPy. But this alternative does not have a built-in global interpreter lock. That's the point. So let's start with an example. This is the result of running. I ran it before on my laptop. So it is Richards, which is some random benchmark, some CPU-intensive benchmark. Here I run it like a total of 10,000 iterations, so divided in 4 threads. So here it's just naively using thread.start new threads in order to create 4 threads. Each of these 4 threads runs for 2,500 iterations. Okay, and we see how much time it takes. This is the time, so 8.01 seconds is how long it takes on PyPy, the regular PyPy, so with a GIL. And without a GIL, it takes only 2.5 seconds on this laptop, which is a 2/4 core laptop. So it's good. This is an example where it works great, I suppose. Yeah. Okay, so well, I mean, obviously, such an example as Richards, well, if my goal was only to run 4 Richards benchmark in parallel, then well, I could run 4 processors. That's kind of obvious. Okay, and then if you are into running sub-process, then maybe you are already using this multiprocessing module in Python, which is basically just running sub-processors. The advantage of running sub-Python processors is that each process has its own global interpreter lock. So if you are not using, I mean, typically in this case you are not using threads at all, so it does not matter. But then
of course, the big drawback is that if you're running in different processes, then well, your data needs to, well, you have different processes and you need to pass data around, which is, well, which can be hard, basically. You cannot take an existing big and complex into a multiprocessing program. That does not work usually. So by opposition, PySTM is about running multiple threads in one program, and well, the idea is that you have shared data, and you can use the shared data, which is both good and bad. So here is an example where I want to look at code. So this is an example where I create a random graph. So it's about here, create my list of vertices. Then I have edges that are from a random vertex to another random vertex. And the goal here of this algorithm is to find the 2 points in this random graph which are as far from each other as possible. So, I mean, which is a specific problem which I'm sure has nice solutions from a graph theoretical perspective, but here it's really the most naive algorithm. I take 1 point, enumerate all other points that I can reach, etc. So it means really try from every single point to reach all other points. So this is a function that given 1 point, find the furthest point here. And here is how I look for the answer. For all starting point, I put in a queue the starting point, and then I get the results from another queue. And my queue is this. So I get a point, I compute what is the furthest, and put the furthest back in a queue. And why am I talking about queues? Because well, I want a multi-threaded program. So what do I do here? Yes. So I have a loop that starts some number of threads and gets me 2 queues. This is mostly standard Python, right? If you ignore the fact that the queues are from the transactions module, you can think of them as queues from the queue module. It's standard Python. But the point is that if you run this in the standard Python, then you don't get any benefit from this multi-threaded, well, hacks, basically. Okay, well, here you do basically the program is unable to be run on multiple threads in parallel. Well, or it should in theory, but alas, this particular example which I quickly did yesterday, does not actually show any huge speedups. Too bad. Yes. I know it's a bad example, basically, but have you seen before, and as you will see afterwards, there are other examples that are larger programs, and for these larger programs, it seems to work better, which is good. So basically, I'm going to assume that you trust me, and I will show you now another larger program in which I did the exact same transformation. So this is a program that was already around 2011, I think, where I did the same demo. So it is a 3D renderer, entirely in Python, and the 0.9 is the number of images per second, because that's on CPython. Okay, it takes forever, basically, but you can see it's changing. And then Boom. Then if I run it on PyPy, whoa, it's much faster. PyPy is great. This was the 2011 talk. But now, let's run this render on multiple threads. That's the point of this talk here now. Up. And you see that it's about twice as fast. It's great. Yes, so this is just a pure Python rendering system. You can see that it's not just calling OpenGL or whatever, because it's using cylindrical projection. See, the wall here, it's not a straight line. Just a random comment. Okay, so okay, now what does it mean if I have a multi-threaded program in Python? Well, this is this is a summary of in normal Python, so CPython or PyPy without STM. This is a summary of what you can expect from a multi-threaded program. You need to divide your threads in two categories. You have the threads that are doing input-output, so they are typically blocked in some operating system call, like file.read or receiving from a socket or doing things like that. And you have, on the other hand, the kind of thread that is CPU intensive, that wants to compute. So in standard Python, with the GIL, typically you get this result. So, and you can have any number of threads doing I/O, that's fine, that works great. But you can have only one thread that's doing CPU-intensive computations at a time. So now, if instead you're using PyPy-STM, you get this slightly strange result. Well, you can have any number of input-output threads, okay? And instead of one, you can have up to n that are doing CPU-intensive things, where the number n is actually compiled into the PyPy-STM. So that means, for example, here I'm using a PyPy-STM with n equal 4, I think, but well, you can have one with n equal 8. Typically you will get one with n equal is the number of cores on your machine, or well, I don't know, a number larger than the number of cores of your machine would work as well. But well, so far so good. However, the problem with the approach in PyPy-STM is that only one thread at a time can be switching between these two modes. So I have an example. Yep. This is a completely trivial example. I have my run thread, which, with the print I commented out, it's purely computing things on the CPU. If I run this on PyPy-STM, it will happily use 4 threads. Good. However, if I run this on PyPy-STM, then things get slow again. Because each thread is trying to be the thread. Well, it's basically because each thread is switching from I need to compute stuff, like this line here, to I need to do input-output, which is that line here. So this is the main drawback, basically. This is the point to look for when you are using PyPy-STM. You need to find and, well, fix, quote, somehow this. And I mean, in general, yes, it can occur, for example, if this is doing some complicated computation, like rendering a web page or doing this kind of stuff. But then in the middle, you get a call to the logger to write the logs. So, well, in this situation, you need to think and refactor your code so that the call to the logger would be moved somewhere else. So this is, to conclude the first part of my talk, this is PyPy-STM. You get compatible with standard Python, well, as much as PyPy itself is compatible with standard Python. You get multi-threaded programs that happily run out of the box. And, well, still a few bugs, but try it out. Now, I promised at the beginning that I would explain what STM actually means, software transactional memory. Well, what is a transaction? Well, let's look at it this way. You have a program, and think about how the GIL, the global interpreter lock, works in CPython, for example, or in PyPy. The GIL is acquired, then you run stuff, then you release the GIL. And when you release the GIL, you do some input-output, maybe or maybe not, and then you reacquire the GIL. So one transaction, what I'm going to call a transaction, is the amount of time between the acquire the GIL and the next release the GIL. Why is it called a transaction? Because that actually is very similar to database transactions. Why is it similar? Because, well, what is transactional about it is the complete memory, all your objects. You have to look at the complete memory used by your program and think this is the database. Well, think about it as a regular database. What you have in a regular database is transaction, you do some reads and you do some writes. As long as you do reads and writes, you have a consistent view. And at the end, you try to commit. And this may work, or they may cause an abort. So it means the commit fails. The commit fails if someone else did in parallel another transaction, and that other transaction happened to change object that you have read. So this condition is exactly the same one as the one used in software transactional memory. So this means that you run, so let me draw pictures in the air. When you have the normal CPython, you run one thread, then you pause it, then you run another thread, then you pause it, then you run again the first thread, and so on. And with this transactional approach, instead, you start running both threads. One commits, okay, the other one continues, then the other one tries to commit, and then it may either succeed or fail if there was a conflict. And if there was no conflict, then you are happy. Then the two threads work as if they had been executed one after the other. And well, if there are conflicts, you are unhappy and you throw away what you did and you restart it. So one difference with the standard transaction and system of database is that here the throwing away and retrying part is transparent. You don't see it at the Python level. Yes, so here is how it works under the hood. Maybe I will go a bit faster here. So basically, during a transaction, you flag all objects that you read, and you record a list of all objects that you write. And when you commit, you save that list of objects that you wrote into some log. So there is a growing log. And well, basically you have a simple to describe algorithm to know that well, if you have a conflict or not, which means basically if you have read an object that another transaction has written in parallel, so concurrently. Yes. So as I said, Abort-on retries are transparent, but that also means that you can do, well, the input-output, like if one thread is really trying to do input-output, obviously, once you do input-output, you cannot be cancelled and retried. So only one transaction can be flagged as, now this transaction actually did input-output, so this transaction here cannot abort anymore. Yep. Okay, and well, everything that I described so far is basically something that looks a bit like what Larry Hastings previously explained in his talk, to how to make a Python interpreter actually not have a GIL. However, this approach that I'm using here, STM, is better, I think, than the approach of adding locks a bit everywhere, because it also allows, well, it allows another style of programming. What do I mean? I mean that, well, you know that there will be no switch to another thread in the middle of a bytecode. But this you can actually add a small hack with Atomic, and with this you can make sure that there is no switch to another thread in a larger region. So this actually gives an interesting model to program with multiple threads. You can make programs that have actually large region, and these large region, just by saying with Atomic, you make sure that there is no possible switch. Well, you make sure that this whole block of Python code runs in one transaction. So what it means is that you can have actually this kind of interface. Well, this is just a simple thread pool, right? You add some function that will be called later in another thread with some argument. You say tr.run, and then all the functions that you have added are executed at that point in multiple threads. However, this runs them with the Atomic context manager that I described before. So it means that it gives exactly the impression to the programmer that each of the functions has run completely serialized. So I mean, even though the various functions are run in parallel, the transactions that are done here under the hood are each large enough to contain completely the function calls, which has, well, basically it gives an incredible model. It gives, well, yes, I'm a bit running out of time here. But what I'm trying to say is that this is the model that I think is kind of the future of multi-threaded programming. At least if you are fine with generally if you're fine with not getting to the last 10% of performance or something like that. This is a very nice model to program. I mean, my 3D viewer that I did before, it's just parallelized by, so you compute column by column but each column, you send it to another thread. So you have a thread pool that computes columns. But each column computation is done in a with atomic block, which means all the logic to compute one column, even if the logic depends on some global variable or does things like it can do whatever, it will work. It will work the same way. You don't get any race at the level of Python. Okay, so yes, that's it. We have time for 2 questions, and then we must leave the room. So I will be outside afterwards. Just.
I think you worked around the effect of the print statement, right? Because you cannot make a rollback then. Yeah, because transactional memory, as you said, on some memory matrix or whatever. But when you have an effect like the print statement, you cannot roll back.
Yes.
But Python has no effect system, something like that. So effects are not annotated. So how does the PyPy STM knows when it detects an effect, something which manipulates the outside world?
Well, it's when the standard PyPy would release the GIL. At that point, you know that something strange is going to occur.
Okay.
I mean, that's not the complete answer. I can give you a more precise answer, but that's roughly where.
Anyone else?
Would you merge the PyPy STM to the main STM branch someday, or
the main PyPy branch?
The PyPy STM, because
Yes.
I think it's a branch of
Yes.
PyPy.
Yes.
So will it become the default in PyPy someday, or will it be always
You're
two
right.
different branches?
Excellent question. I don't know so far. I mean, this has a problem that it is between 25 and 40% slower on a single thread. So again, the same problem. So I don't know, basically. But, well, here we are in PyPy, so it's possible to think about more advanced ways where the PyPy interpreter switch between codes and, I don't know, JIT-compiled machine codes for the non-STM mode and for the STM mode or something. So it's possible that at some point it will be the case, yes. Thank you.
All right, welcome back. Welcome back for this third day of Lightning. Hooray! Our first day was amazing, and the second day was double amazing. This will be triple amazing. So, what was I going to say? A couple of little announcements. If you see anyone walking around with a badge like this, these badges are beginner mentors badge. So let's say the person wearing this badge is happy to answer any questions you have. If you're a beginner, and that doesn't mean a beginner at programming, but in any topic, you have a question, and that person will automatically be an expert in that subject and reply magically to you. No, I mean, that person is there to help with any questions you have. Questions about the conference, questions about what talks to try out next, question about who to talk to or where to find out more information about something, whatever it is. People wearing these badges are specifically very happy for any questions. Interrupt them halfway through a conversation, whatever it is. It's our job as beginner Monthills to... Yep, what's the question? I'm here to help. Shh. Sorry? Okay, so there's some bathrooms if you come out immediately on the left and also a little bit further back on the right. You're welcome. All right, so that's the Mentor's badge. The other thing I wanted to introduce is, God, I'm going to say Fabian here, who is talking about the mouse icebreaker. So you may as well remember the story about having an icebreaker game that's going to encourage people to just talk to each other and say hi to strangers. So Fabian has come up with some cool rules and a cool game. The explanation is outside by the door, but a quick explanation in person, I think, will help to really make it concrete. I've already started on the game. It's going great. Okay, hello.
So after the lightning talk yesterday evening, there were quite a lot of people that were interested to help and do something. And we figured out some, well, let's call it the first iteration of a game. It's just that our PR department completely failed. So there is a board somewhere here directly. If you're coming out of the room, then you'll see a board, and there are the game rules, but I think hardly anybody realized that. Maybe with a show of hand, who realized that the game is already going on? Yeah, okay, but well, now everybody of you knows it. Directly there are the rules, and we'll continue tomorrow. And the thing is that, unfortunately, 3 viruses have spread through all participants. And in order to, well, the objective of the game is to disable those viruses on your own software, on your own operating system. And you need, for each one, a code. One code is very easy to obtain because it's a static code. It's just one certain code, and as soon as most people know it, it's very easy. You just ask, do you have the code? And at some point, everybody knows it. The other 2 codes are a bit more difficult because they are personal codes. They change, and we have a really, really electronic gadget. Well, it's actually a piece of paper. But we call them, what do we call them? Emitters. They are code those pieces of paper, and there are some emitters that are moving around. So as soon as you go around and ask, hey, do you have an emitter? And if that person has an emitter, then you will have that from then on. And so you have to just go around and ask. And the third one also is with an emitter, but the emitter stays with the person. And those are the persons that have, oh, I don't have my badge on, that have a little mouse. A hand-drawn mouse on the badge. Those are the game admins. They also know all the rules, and they have another emitter. And if you have all 3 of them, I will ask tomorrow in the lightning talks who has the most codes. So, play the game.
All right, so our first speaker is Julian Tebolt, and for setting up, getting ready before that, I'd like Philip Chebchik. Okay, Philip, where are you? Wait. Okay. Fantastic. All right. Is there anything that's on your mind, everyone? What? How do we get a badge? Oh yeah, so if you'd like to be a beginner mentor, we have an oath that you have to take. So there's a little bit of training, you have to swear to do certain things and promise. I based it on the oath of the Night's Watch from Game of Thrones. So if you just come and see me afterwards, I'll explain the oath, and if you're prepared to take it on, it's a big responsibility. It means that you have to be prepared to stop trying to impress your friends with your incredibly geeky knowledge of technology that you've learned this year, and instead just go, oh, sorry, okay, fine, I'm answering your question about beginner issues from now on and for the next hour if necessary. So it's a big responsibility. You do need help. So come and see me afterwards, and I will definitely give you a badge if you swear the oath. On that note, are you ready, sir?
Yeah.
Julien, take it away.
Okay. At first, sorry for my accent and my mistake. I'm French, so I will try to do my best in English. My talk is about MongoDB as a tostada. I want to compare MongoDB database with a tostada. Tostada is a huge, huge cake. Last night it was a nightmare to finish it. Even more after 8 years, so many tapas. MongoDB is also a nightmare when using or missing indexes. I know people say MongoDB is slow, it's not acid, the query language sucks, but I love it.
6 people.
Okay. The tostada, as you can see, is very, very fat. To prevent MongoDB from becoming a tostada, you must monitor the slow operation. So how to locate and trigger an action on long-running operation. You can use the profiler or current OP, but it's impossible to trigger a specific action. Let's go. So we have a simple live demo. I will try to simulate a slow operation. Okay, sorry. So, as you can see, I'm trying to find a bottleneck, which is a tostada. We can retrieve some information about the current operation with current OP, but you need to wait the end of the operation. As you can see, it's very, very, very long. So, I wrote simple tools. Is a mongoop. You can set different trigger. You have a killer trigger. It tries to terminate a long operation, and you have the MongoDB trigger. It's a simple insert on another database. Yes, okay. I run mongoop, okay, and I try to the same operation. You can see the first action is trigger, and the other is trigger. And now the operation was interrupted. So it's on GitHub. The project is not mature, not enough to be in production. I need more tests, more triggers like Sentry, ERC, InSCA for your monitoring tools. Maybe Python 3, but I'm a little confused with that. And I need your feedback and your help. To finish, if you want to try to eat the tostada, I know the restaurant.
Okay, Philip coming up, and then after Philip, we've got Daniel Mild on PyBenchmarks. Good. All right, anything else on your mind, everyone? Yeah, what's that, the what? I kind of forgot what the beginning of the story was. I don't know if I can actually... Yeah, exactly. I don't know if I can remember the whole thing unless I start at the beginning. So maybe we'll do that. Like, what was it? It was about a man who really likes tractors, isn't that right? So, where were we at the end of it? Do anyone, where were we in the story? Who remembers? So everything was on fire. He was burning all the old tractors and the old tractor posters. But I guess maybe, now that you've reminded me, we can have the rest of the story a little bit later. So, take it away, Philip.
Hi, I'm Philip. I'm the main organizer of PyCon-PL.
I'll go and clap him. Yeah, come on.
And I would like to talk about PyCon-PL. So, I kind of made a bit of research and to see how are PyCons in Central Eastern Europe doing. I've noticed that PyCon-PL is the oldest one, but new PyCons are appearing. I would like to encourage you to try to attend, propose talks for those PyCons. This year, there were many new PyCons in the Central Eastern Europe, for example, PyCon Belarus, PyCon Lithuania, and there will be PyCon Czech in November 2015, and the next year there will be a first PyCon Slovakia. But I will talk about the PyCon-PL. So, our PyCon is a bit different than other national PyCons in the sense that we are not picking big cities, you know. Probably the name of the cities or town or villages that we are organizing the conference are totally unknown to you. So that was kind of our idea. So we are kind of booking one hotel, and all attendees are staying in the hotel, almost, because people that are living nearby probably want to stay at homes. And that way, our PyCons take place in completely different areas, usually close to the nature, so mountains, forests, and I think that's kind of pretty cool. And what are the advantages for attendees? So you don't have to worry about reaching back to your hotel at social event because you are everything happens in the same place. You don't have to worry about the weather, about unexpected rains. So everything is closed, hotel room, conference room, bar. If you forget something, you can easily go back to your room and take it. If you are kind of tired and need to rest from everyone, you can go hiking. And this kind of approach also gives us opportunity to superb socializing. And now about the current edition. It will happen in the mid-October in a village called Ossa. We'll have 6 tracks. There will be 2 English tracks, 2 Polish tracks, and 2 workshop tracks mixed. Some of them will be in English and Polish. We are expecting 600 to 700 attendees. Last year we had 5,000 attendees. So we are kind of growing every year. Full ticket includes hotel room. It's a 4-star hotel and meals during the conference. So regarding the speakers, as you see, we have speakers from different countries on PyCon-PL, and I think that's very good. We'll also have a PyLadies workshop from test-driven development. I must admit that the kind of diversity problems are also applying to us in Poland, and we need more women speakers. On this edition, we'll have 5 women speaking, but even though the call for proposals is closed, you can still submit a proposal. We'll try to find a place in the agenda. So where exactly is PyCon-PL 2015? So it's in a village, as you see. It's 1 hour from Warsaw, so this is important. This is the view from the OpenStreetMap. Actually, a month ago, there was nothing on OpenStreetMap there, but thanks to the OpenStreetMap community, we have the hotel complex mapped. That's how the place looks like. You know, because it's in the middle of nowhere, then kind of bus transfers are important, and there will be special buses organized by us that will go to the hotel. There will be many activities during the conference. Follow the White Python Coding Challenge. Every night there will be board and card games. There will be a grill and barbecue party on Saturday. Every night there's a party going on the dance floor. And if you want to come with your kids, there's a special program for them. so you can enjoy the conference where your kids are under good care. That's the view of the auditorium. There is a free swimming pool, jacuzzi, and sauna for all the attendees. Yeah. So these are the prices, and I think these are actually really cheap if you compare with other conferences. So for a ticket, you can buy for 190 euros, and it includes accommodation in the hotel plus meals. That's how the hotel rooms look like. If you think that's too much, you can apply for a financial aid at our website. These are the comments, and I think that comments of our attendees say a lot about the conference. It's worth to attend. So have a look. The last comment is, still waiting for my ears to stop ringing after 3 nights of disco at PyCon-PL. We have different games during the evenings. Different groups are meeting. Yeah, kind of. I'm going fast. And in Poland, we don't eat sandwiches on lunch.
Amazing. So after Daniel, can we have Rob Collins? Are you near the front? There you go, that's good enough. And after Rob, it'll be Philip Fritzi. Are you here somewhere, Philip? Fritzi? Yeah, close enough to the front to be able to run in? Okay. All right, fantastic. So our guy who's just gone crazy with his tractor, has gone too far. He's decided to just quit. He's piled up all his tractor memorabilia, all his pictures of tractors, all his old tractors. He's put them in a massive bonfire in his garden, and he's going to set fire to it. And he's just watching it all burn away, and he's like, that's the end of my old life. No more tractors. I'm finished with it. And he's sort of sad, but he's also like, this is a big milestone for him. And he feels like ready to move on, ready to put it behind him. Are you ready?
Not it.
Okay. So he's ready to put it behind him. And he after this is done, after it's all gone, he just goes, that's better. I feel better. I think I'm going to go for a drink. So he goes down to the pub. He walks across to his village pub. And he walks in, and the pub is kind of empty. And there's not many people around. And I think the reason he smells this weird smell. And he goes, I think the reason this pub is empty is because there's a really bad smell in here. And he goes up to the barman and he goes, hey, what's going on with the smell? And the barman goes, I don't know. It's been like that for days. Still waiting? Oh, that's loading, is it? Okay. Look at that. Take it away.
Okay, so hi everyone. How many of you know the computer language benchmark game? Okay, so as you may know, it's a great website where you can compare the performance of different programming languages. But there is only one Python interpreter available. So, and we want more because we have many interpreters. So, fortunately, the project is open source. So I created a fork. It's called pybenchmarks.org. You can see it here. It looks the same as the original project. So now you can, for example, JITON, but wait, no, you don't want that. So once again, you can compare, for example, PyPy 3 to Cython, or you can have a look at how the new Python 3.5 is doing, or compare another nice compilers and interpreters. So pybenchmark.org. The benchmarks are not perfect yet, of course. So if you want to participate, there is a link to source code. It's on GitHub. So please feel free to send a pull request. That's all. Thank you.
All right, Rob, you're up next. And Philip is after that. Okay, so he's gone to the pub, and there's a weird smell. And he's like, what's that weird smell? And the barman goes, I don't know, it's just been It's been like that for days. And the guy goes, you know what? I think I can help you with this. And he walks to around the pub for a little bit, and he's trying to smell the place where the smell is strongest. And he eventually stops it, and he goes, all right, I think it's here. And he goes like this. And then he walks out to the door of the pub, and he goes out the door of the pub, and he goes outside. And he walks back in, and he goes, and he walks back outside. Are you waiting to talk?
Oh. I'm waiting for Windows. Sorry, guys, it's not
Okay,
my...
No, that's all right. We've got about 15 minutes of this joke left. So
have a good time.
he goes back into the middle, walks back outside, and slowly the smell is disappearing. And the barman's like, this is crazy. And he goes, walks out a few more times. Like that. And until he does this several more times over the course of sort of a few minutes until the smell is completely gone. And the barman goes, that's amazing. I've never seen anything like that. What happened? Like, how did you do that? And the guy goes, well, you see, I'm an ex-Tractor fan. There you go.
Now we wait for Mozilla.
Okay, not bad, huh? I know several more stories in that sort of vein. There's one about a paint program in the 90s and a Chinese conspiracy theory. But that like very much relies on people having a decent knowledge of like early 90s desktop software. If you have a good knowledge of early 90s like paint software, put your hands up. Okay, so that's like 35%. So should I waste like everyone's time for a joke? 35%? I think so. No. Philip, take it away.
So, thank you. My name is Philip, and I am DevOps and a paranoic. In my world, there is a new revolution: containers. Containers at most everywhere. There is a few applications to run new containers, like runc, Docker, Rocket, Vaga, LXC, and so more. But there is no one application in Python, right? But there is a Python conference, so I create a package, PySpaces. It's try to implement some containers, Linux containers feature, like namespaces, cgroups, and so other. There is a lot of work should be done before it's ready for production. But I hope you enjoy this package and help me to create great application for containers for development and deployment. By the way, I'm a member of the Belarusian Python meetup, and you can find our community at Facebook and at Twitter. So enjoy us, and we should take a part and create together new big challenge, new world with Python. Thank you.
Fantastic. I had a good one. Yeah, so we're probably not going to do the early 90s paid program. I have another joke, if you like, that's like really highly dependent on people knowing the meanings of two words. So like, would you put your hands up if you know the meaning of the word apposite, A-P-P-O-S-I-T-E? Yep. And the word pachyderm, P-A-C-H-Y-D-E-R-M. All right, now if you knew both of those together. All right, you guys, what do you call an apposite pachyderm? A relevant. Okay, because apposite means relevant, and a pachyderm is elephants and rhinoceroses. Yeah, pretty good. I was pleased with it. Yeah. What do you think? Like the jokes I make up versus the jokes that are real jokes? How do they compare? Yeah. What do you think? Like Extractor fan versus Tina Turner. Which did you prefer out of this? Like hands up for Extractor fan. All right. Turner? Yeah. Guess which one I made up? What? Say what? That's pretty much what I'm doing, guys. Like, how do you make up a joke? Well, the Tina Turner one, right, you can pretty much tell. I made that up in the shower, because and then I thought, second-hand emotion, second-hand in motion. That's it, and you just work backwards from there, just figure out a long story where, like, somehow there's going to be a reason for someone to say that, and you're there, you've got a joke. It's amazing. How are you getting on over there, Rob?
Okay.
Yep, all right, it'll take some time. How about a joke that's like...
No, I'm okay.
Oh, you ready to go?
Yes, my picture's not scaling, but I think that's the point. So first of all, I'd like to say thank you for those who participated in the sponsored massage. So hands up, who's had a massage so far? Well, was it good? Yeah. Well, it's not too late. We have one more session tomorrow at lunchtime for you to get a massage and to give money to the Python Software Foundation. So we had 16 people doing the training on Tuesday, and they made a good team, and spreading out, talking to lots of people and giving massages, we've raised over €1,000 for the Python Software Foundation so far. Now, there is a problem. Great team, but we haven't covered everyone at this conference, and there's a bust factor of 1 that it depends on me being here and doesn't scale even in this conference, let alone at other conferences. So I thought, what about we try and write things down, help other conferences be able to do the same thing. Other Python conferences could raise money for the Python Software Foundation, could scale to other programming languages and other good causes. So I need to delegate, because it isn't that difficult to do, but it's not trivial. So there are some things, and we were thinking, well, supposing we had a website to help groups be able to organize a sponsored massage so that other people could do it. Now, show of hands, do you think that would be a good idea to do that? And anyone not asking for help, just sort of your opinion of whether you think it might be or not, right? Yes, well, no, I'm not asking for more donations. I'm asking for some help. So I'd like you to think about how you could help, not just for massaging, but for organizing, designing, writing things. So this isn't going to scale properly here, but if I can get this there. So the pythonmassagefoundation.org, go to the website. The only thing it does is to allow you to subscribe, put your email address in there, and we can build something that will be actually useful for other groups to be able to do the same thing with more teams of people and raise more money for good causes. Please go there and or talk to me afterwards. Thank you.
All right, Patrick Goodry on PyTest and Selenium, and after that we've got Alof Bradbury.
Alex Bradbury.
Yeah, Alof is a good name too, though, right? Yeah. Okay, that's someone I actually know, everyone? Yeah, Alex Bradbury, yes, fine, okay. Are you close enough to be able to run up and give the talk? Would you like to move to the front row, maybe disrupt now rather than later? Jolly good. Yeah, so come on, rather than having another really tedious joke, you know, we all talk about community a lot in Python, and that's not a word that meant a lot to me for my first few years in the Python community. And I was like, well, I don't know, you know, I'm British, I don't like to talk about my feelings or express them, or really admit that they're of any use. So community sounded a bit wishy-washy to me. And I think the first time I really got it, I was in a DjangoCon, and the setup was that they were going to announce Django Migrations, which was made by a man called Andrew Godwin. Are you here, Andrew? What, Andrew? Well, someone called Andrew put their hand up. And he was going to announce that the Django Migrations is merged into Django Core from being a separate project called South. And I'll finish the rest of the story after this talk. So Patrick, take it away.
Hi, everyone. Well, as previously stated, my name is Patrick Cudret, and I work for Numbly. We had a lot of nice talks about tests and test-driven development, mainly for command line tools. I'm a bit lazier than that, and I had to test pages, HTML pages with links and whatnot. So here is to just take tests in that direction just a bit, so you don't have to manually click on everything. So first, I use PyTest for my tests because it allows me to build either unit testing or functional tests. It supports what it calls fixtures, which are a nice way to prepare your environment. Well, depending on what you run, it can be either fast or not. Well, if you sleep 10, it will be slower than expected. And it has nice reports, as you can see right here. That's the kind of report you get with the number of tests failed, number of tests passed, and you know which one failed and what it failed on. For those that might not know what Selenium is, it's kind of like enabling ghost possession of your computer. You program your Python script, and it just goes opening stuff and manipulating your brother, well, your brothers, actually, as it supports more than one. And what we are going to do is trying to use them both together. That way, all the tests you had to do are going to be done automatically, and you can go sword fighting on shares. Okay, so I have a very lightweight Flask app that runs mostly nothing. It has one simple input that puts the text in the page, and one link that just redirects to another page with another link. So running Selenium is just going to open the browser and do stuff, but as you can see, I have no idea what has been going on. So running PyTest, I can see that he has four tests to run. Ran the first one correctly, the second one failed, third one passed, fourth one passed. And now I can see that actually, yes, the second one failed, and I know why. The actual code for the PyTest tests is really lightweight. The only thing is to define your fixture. You just instantiate your brother, yield it so you can use it, and quit it just when your test is done. And that's it. You got here the PyTest website, Selenium website. Be aware that Selenium strictly Python. It is also available in other languages. That URL is to access the presentation available, and that's the whole code for this lightning talk, including the very lightweight Flask app. Thank you.
All right, after Alex, we've got Tom Bollinger. Are you around, Tom? Here. Hooray. Okay, so South, the migrations framework for Django, who's used that? And who's used Django migrations? All right, so there was a guy called Justin, who you might come across if you go to a lot of Python conferences, who's a lovely guy. And he's going to be, hey, Harry, and like, it took someone American really to kind of explain this community thing to me, because the Americans, unlike the British, aren't afraid of talking about their feelings, Justin in particular. And so he said to me, hey, Harry, man, are you going to Andrew's talk? I went, no, can't be bothered. South is already really good. I know that Django migration proves it, but it's more or less the same. The only thing I want to hear is like, hey, Andrew, is it more or less the same? Yes. Did you do a good job? Yes. Will it all be obvious? Yes. Thanks very much. Goodbye. Talk I want to go to. And Justin says to me, man, that's not the point. The point is this is Andrew's big day, man. Like he made this tool South that we all use all the time. And like it makes our lives so much easier, man. And like we love it so much. And like he's finally come into the Django core, man. Like his project is recognized. It's a part of it. And we've just got to be there, man. We got to be there for his big day, man, to just be there and be present and like say thank you, man. Like we are grateful. We are grateful to you and we are here for you, man. And I didn't actually end up going to the talk, but I was almost ready for that lesson, but not quite. But you know, that's the sort of thing. So I hopefully that, yeah, that's the sort of thing. Alex, take it away.
Thanks. Hi, so I'm not
doing my clap well enough, but I'll try and set this up.
Hi, so I'm Alex. I'm a researcher at University of Cambridge, and for a number of years I've been working with interns over summer working on Raspberry Pi related projects. And so this project, PiLand, is something that a bunch worked on last year and we've continued this year. And I thought I'd tell you a little bit about it and how you can help us out in our aims. So PiLand aims to be a game which helps to teach children to learn to program using Python. So to take a little step back and kind of motivate this a little, some of you may have seen this before. This is called MIT Scratch. So this is how a lot of children may start out learning programming. It's really nice, it's visual, it's easy, you drag and drop, you can draw your little fish and you can easily add behavior to them. And that's great. And so children at kind of end of primary school, maybe 7 years old, don't want to move on to something new, so you move on to Python. And then to get to where you were with Python get to where you were here, where you could have all this, interactivity, moving images, making your own games, actually takes rather a lot of time, which can often be rather off-putting. I mean, this is a kind of translation of what was probably the first kind of program that I wrote. So on my Amiga 500, I had a trouble that I only had a BBC Basic book, so I was very frustrated that that not everything quite worked properly in Amiga Basic. But I was very excited when I had a knock-knock joke thing. I went to show my mum, and I thought this was fantastic. But one thing I've learned in life is that not everybody's like me. In fact, quite a lot of people aren't like me. And for many people, just something simple and textual, which prints something out on a screen, in a world where you have, your mobile phone can do amazing things, you go home, you play your PlayStation, your Xbox, that's not all that compelling. Although for many people it does give a good sense of achievement. And so what we're trying to do with PiLand is producing something which is graphical, it's intuitive, it's to children, so that you can write Python and get something which is but you're kind of motivated to write it to move on to solve puzzles in this game. And here is obviously this is a kind of the edit isn't quite finished, so it's a little bit of a mock-up. But this is all showing the graphics that we had made for us last year. And obviously this student here is about to be told off very badly for not obeying PEP 8. But I'm now going to be slightly risky and give you a demo of what it looks like currently. So if I Alt M, there we go. Yeah, so this is our little guy, Ben, he's our main character. On a level screen, I can move to a level here, say, where we've got our crocodiles moseying about. So each character has a Python script which you can use to control their behavior. And of course, I'm just using my arrow keys here. Unlike some programming games, we don't try and we don't want to force people to program in cases where it's not actually helpful. That's only going to put them off, whereas you have to open a text editor just to move left or right. So this is a simple level where we have another character, Milo, who's our little monkey friend, who is going to help us out. I know, Milo is definitely my favorite character, the way that the animations come out there. So that's kind of... So we've been working on this last year. We've got a bunch of, a team of 3 interns working with me this year to try and get it towards something that's releasable, that we can share more widely. So the aim, as I said, is children, kind of ages 10 plus. We're kind of practicing, as I said, intern-driven development, where it's very much limited by manpower there. So the game engine itself is written in C++ and is increasingly Python scriptable. I should point out that one of the key requirements is that it has to run on the original Raspberry Pi, so the 700 megahertz rather weedy ARM, which limits your options somewhat. Which is very difficult because quite a lot of schools already have these, and of course it's all fully open sourced. And so our aims, the things we're working on this summer, so we've had a few weeks with the amazing set of interns they've come up with this kind of story about you're on this island and there's a group of people who can both write and run programs, there's another group of people who can only run programs, and you have to help the people who can only which it sounds like it could be very, very political, but that's not totally the aim. And so our key aims this summer have been working on more content, making it so it's easily extensible, so that you can write levels in Python, so that you might have a teacher who modifies or customizes them. Children might be able to write their own levels and share them with their friends, and working on this integrated text editor, whereas currently you have to kind of switch to a separate window. And so if you want to get involved or look at what's currently there, go to pyland.org, follow us on Twitter, talk to me afterwards. And also thanks to Raspberry Pi Foundation and the Broadcom Foundation for funding this, and a big thanks to all my interns this year and last year for all the actual work. Thanks very much.
Tom, you're up next. Okay, guys, so it's 6 o'clock, so Tom should be the last talk. Would anyone like to stay around for longer? By applause, stay for longer? Versus by applause, go home, go to bed, go and have food, go to sleep, and just generally relax. All right. So that has it. So I'm going to propose that we stay for another 20 minutes or so. Anybody that is actually knackered at this point, this is a good time to leave while I'm talking, because that's just a waste of time. Whereas while Tom's talking, that's going to be interesting, entertaining, intelligent, fascinating, warm, loving, community-based, and all sorts of things like that. Are you ready, Tom?
Every one of those things, yeah.
Wait, yeah?
All set.
Yeah? Are you sure?
Yep.
Give Tom a big hand!
Great.
Well, all right, I want to tell you about something that it's almost generous to call a hack. It's somewhere between a hack and a joke. But this is RL undo. It's undo in any interactive interpreter with an asterisk there I will explain later. So I work on a project called BPython, which is pretty fun. It's got undo, as you can see here. We hit a button, and then we undo the state. And then A isn't even defined anymore. So we've undone the state here. We're taking the entire state of the program, kind of rewriting what we want it to be. And just from this little briefing of what you've seen so far, imagine for a few seconds, how might you implement something like this? The undo part here is what I mean, where we can go back, and then that variable isn't defined anymore. We've undone that thing. So think about it for a second or two. It's a pretty dumb way, what we're doing. What we are doing is, well, I have to explain it first. What we're doing is just replaying the state. So we just remember all the commands that you ran, and when you undo, we just redo all of them except the most recent one. And then when you undo again, it does again. So this works pretty well when you're trying out the syntax of something, but if you're trying to do real work and do something that takes 10 seconds, it's going to take 10 seconds to rewind your most recent thing. So useful, neat, but limited. So where does this fail? It takes time to rebuild that state. While you're rebuilding that state, you might use non-deterministic operations. We don't reseed random or anything like that. And maybe you're doing non-idempotent stuff. You're appending bytes to a file, so that happens each time you undo. File system changes, we're not going to have a whole VM and then rewind those file changes, and we're certainly not going to simulate the universe and recall those bytes from Google that fired the missiles or whatever. So that's kind of out of scope, but we could move down a little bit. We could accomplish some of these first ones, and the way we could do that is by saving snapshots of states instead. What if instead of rebuilding the prior state each time, instead we save these snapshots and just return to them? Obviously, this would have higher memory requirements, it seems like, but we get around the rebuilding time. We get around running things twice, and there are side effects happening twice. Right, those higher memory requirements, probably a problem. Let's try to do this copy on write thing. Functional programmers talk about this a lot. They're like, ooh, in Clojure we have these data structures that are immutable, and we can do this clever kind of, when we make a copy, it actually refers to these things, but you have to kind of, and we could do some immutable stuff in Python, but maybe not real general enough. What we're going to do instead is fork. So on Unix, we have this way of copying our process and making another one that looks just like it, and it's doing this copy on write stuff at the operating system level. So that's pretty cool. We could use that to save these states. Let's try to do that. Every time something interesting happens, we'll just fork. Okay. So this is a hack in 3 parts. First off, we're going to use readline. Readline is a program a lot of interactive interpreters use. It's inside the program, right? So that's the same process, and we could fork it to save these. When we can intercept what the user types, and if they type undo, we can just, the previous one will take over, because it's just sitting there waiting. And we have to get readline into these things somehow, so we're going to intercept the dynamic library call. And then we have to rewrite the terminal a little bit. So let's take a look at this. Here it is with Python. I can say, looks like B is there, but if we do this, B is not there anymore. So this is with saving snapshots. But this is with forking, and lots of things use readline. So say that we have, for some reason, we have to use this other programming language called Ruby here, or Racket, or Lua, or a lot of other things that also use readline. Here's A, but then we do this, and it's not there anymore. And we can see if we were to, we can see the process tree here, 3, 4, 9, 8. We can watch this get bigger. So maybe not ideal, but it's copy on write. It's probably great. And we can undo, undo, undo. It looks like we've got off a little bit. So rewriting the terminal isn't quite working correctly. So this is a fun thing. That's it. That's cool.
Don't go away, don't go away, don't go away. I was just the achievement.
That's all. I'll have updates. So it's a joke, right? Is it good? No, it's not a good idea. Redo too, that would be cool. We could save them, you could jump around. So we don't have any of that stuff. But we do, I have tests for this where we're starting to, it could almost maybe kind of work. So if you want to contribute to it, it's at github.com, Thomas Ballinger, all-undo, and that's it.
I want one that just guesses what I was about to do next and skips into the future. That would be even better. Yeah, fine. So what was I talking about with the Andrew story there really is that, like the value of going to a talk is not necessarily like the information that you can get out of it and what you can sort of selfishly get out of the conference. Some of it is also about recognizing people. Yes, so it's me next. That's the important part about this whole thing. So next we've got Niklas Olofsson. And after that, we've got Jyrki Palainen. Sorry, Jyrki. Niklas, are you nearby? Hooray! Yeah. So sometimes you just go to talks because you've got to support someone, and that's nice too. And it's all important, this community stuff, because we donate our time, isn't it? Like open source software, free software. It's all based on the work of and so, you need to get some sort of payback for that, and that payback is going to be nice things like your friends showing up to your talk or people recognizing the hard work that you've put in by just being there and clapping for you, even if they've got no good reason selfishly. Are you ready, Niklas?
Yes.
Yeah.
So
take it away.
So my name is Niklas, and this is basically my first talk ever, so please bear with me. I'm going to talk about efficient allocation of space, and the challenge of this is basically you have a number of elements, and you want to store them in some data structure with some constraints. So, for example, if we have this squirrel who wants to manage his acorns in some way, we can use a box with slots. You can store like 1 acorn in each of the slots. So this is basically an array. But you can only fill these boxes from the sides. And the tricky thing is that the acorns block each other. So if you add like 2 acorns like this, you can't really add any more acorns. So in this case, we are only storing 2 acorns, but we have 7 slots, so we get really crappy performance or efficiency in that case. We can also have like a matrix with multiple boxes, but it's the same like restrictions. You can only fill them from the sides. So how do we fill these efficiently? Well, we could add one acorn, and then add a little bit of space, and a little bit just because there is quite much space, so we can just add little acorns here or there, and then we begin to run out of space, so we start to pack them a little bit more efficient. But even this has really poor performance. Another approach would be to start in the middle, and then don't add a space and fill the first row. Then we could begin on filling the second row and fill the rest of the boxes, basically. So now we get 100% efficiency, which is really good. So let me ask, how many of you would consider using the first approach? Well, one at least. So I basically think that you did when you get in here. So to conclude, dare to sit next to other people, hope that they don't bite you, and perhaps even talk to them and meet new friends, and everything will be a lot more fun and a lot more space efficient. Thank you.
All right. Alex, you're here. Tab complete me later. Okay. Fine. This next story, folks, is set in the undersea kingdom. So it's underwater. And in the undersea kingdom, not everybody knows this, but the lobsters are like the royalty because they're the most expensive. And so there's a lobster king and a lobster queen and a lobster princess, and they all live in this amazing aquatic castle. But then in the stratified underwater society, the most low-class people are crabs, because you see crabs walk sideways, so everyone thinks they're shifty, and you can't trust them. But it just so happens that the lobster princess falls in love with a crab. That's the setup of the story. Are you ready, Jackie?
Yep.
Take it away, Jackie.
All right. Hello, everyone. My name is Jyrki Pulliainen, and I'm going to talk about a thing called manhole. And this is and you dirty people who don't speak English or who don't know the stuff behind the word manhole, it's this. It's nothing dirty. This is actually a manhole. Very more concrete. The manhole is that's just copy-paste on Wikipedia. It's an alternative utility hole, cable chamber, maintenance, blah, blah, blah. Is the top opening to an underground utility vault. You probably also heard about this stupid interview question. So if you've ever been in a stupid interview, you've been where someone asks oh, why the manhole covers are round? And you probably know the answer that they don't fall in, but you can actually next time, when you end up in a stupid interview, you can say to them, and pardon my French because I suck in that pronunciation, the rouleau triangle can also be a manhole cover that doesn't drop in. So you can use that one next time you go into the interviews. Anyway, this all was completely useless, but just a nice fact. I'm going to talk about Python manhole, which actually is a manhole into a Python process. So those who have used Twisted used to have an old manhole and they have a newer implementation, but this is for a layman Python, well, not the crazy callback Python, but the layman Python manhole. You install it by saying pip install manhole, then you import manhole and say manhole.install, or if you just run a random Python process, you give Python manhole environment variable that's just an empty string, and you run your script with that. Then what? What's the point of this? Well, the manhole opens you a Unix domain in a thread. There are options that you don't need to spawn threads, but it actually runs in a separate thread. You can connect to that Unix domain socket with the netcat, or I recommend socat with readline. And boom, it prints you out what your actual Python the threads are doing at the moment. It actually gives you a traceback for each thread. You can see that there's the manhole thread on the top, on the end of the manhole thread, like a traceback, and then this other stuff. This is just running the simple HTTP server and with the Python manhole environment flag. And the best part is that at the very end, it gives you a Python interpreter. So you get the Python interpreter inside the process you're running, and then you can go nuts and do all kind of havoc. And why would you use this is you run, let's say you run a web service or something, so you can actually put like a long-range web service or some other long-range process. You enter manhole there. If it goes derp at some point and you don't know why, like it's running, but you don't know what is it doing because it doesn't seem to be doing anything, you can just enter the manhole and check like actual tracebacks of the stuff that is doing there. The manhole has a decent documentation, but like actually the usage is as easy as it got. How much do I have time left?
I would say 2 minutes.
Oh, yes. Because there was a PyCon Poland, I had to come back to that one. There's also a PyCon Finland. It's the 19th of October in Helsinki. Unfortunately, the call for proposals has already closed, but because they closed it in the middle of July, they're probably going to reopen it because no one does anything in Finland in July except it's on a vacation. It's an amazing conference. We used to have a tagline saying that it has more saunas than the other conferences combined. But the PyCon Poland also seems to have saunas, so I don't know. At least, same amount as other conferences combined. If you don't know, this is Helsinki. Unfortunately, in October, it can look like this. So, 19th of October in Helsinki. Thank you.
All right, after Alex, we've got Łukasz, maybe, for Dream About Flying. Does anyone know who that refers to? And did I get the name more or less right? Wojciech, that's, yeah, better. So the lobster princess falls in love with a lowly young crab, and they have this sort of band relationship. But one day her father finds out, and she's like, oh, I'm not having my beautiful lobster daughter hanging around with one of those shifty, sideways walking crabs. I won't have it. She's like, but we're in love. And she's like, no, I'm not having it. And so he like locks the highest tower of the undersea castle, which I guess makes it the least deep underwater. The like young crab is devastated. He can't see his girlfriend. He really loved her. He's like going around all the undersea bars, like drinking away his sorrows, going, oh, I used to have this beautiful lobster girlfriend. And the weeks pass and the months pass, and the crab is sad and drinking away, and the lobster daughter is in her tower just crying, and the king feels bad, and he thinks, maybe I can cheer my daughter up, and maybe she'll feel better if we have like a big party, and maybe she'll also meet some new and eligible suitors. I mean, obviously no crabs. So I'm going to have a big ball in the undersea palace, and I'm going to invite all the respectable undersea creatures, all the tortoises and dolphins and porpoises and octopi and sea cucumbers. So they're all invited, obviously no crabs, and they have this big ball, and there's the king and the queen, and the lobster princess is sort of sitting next to the throne there, and she's just looking kind of sad, and she's not really talking to anyone. Meanwhile, the young crab is like more and more desperate than ever. Like he's all like, oh no, she's going to be married off to some awful sea cucumber. And the hours pass, and then at midnight, there's this sort of banging on the doors of the undersea hall. Bang, bang, bang. They fly open, and it's the young crab. And he looks all the way across the hall up at the king, who's like right up on his throne the other end. And he walks really slowly right down the length of the hall, 1 foot at a time, perfectly straight, 1 foot exactly in front of the other, perfectly straight, until he gets up to the king and he looks him in the eye and he says, I am really drunk. Are you ready, Alex?
The live demo gods are not smiling on me. So this will be an audio-only demo.
Hooray!
Okay. This will only work on Linux, and what I'm doing now is I'm typing ls in a directory in a directory full of Python files, and because this project uses tox, it's also full of .pyc, .pyo, and a PyCache folder, and it's quite noisy. So when I type my favorite editor and I press tab, I get all those files. I don't want to see them, so what I'm going to do
We can't see
is... Yes, I know, that's why I'm giving an audio description. So what I'm doing now is I'm editing my .bashrc, and you can do the same thing in Z-shell, Z-shell. How do you pronounce that? Anyway, what this line says is, in caps, fignore equals, and then quotes, .pyc colon .pyo .pyd and underscore PyCache. I do that, I source the file, and now when I press tab, I just get my .py files and not all that .pyc rubbish.
Brilliant. I can't hear any of the other ones.
So, sorry for the lack of visuals, but try fignore. It makes the bash terminal quite, just a bit nicer place to be. Thank you.
Hooray! Yeah, those Dunder PyCache files are absolutely deafening. Okay. Wojciech, you're up next. Really? Wojciech? Okay, okay. I'm learning new things. All right, fine. That'll be our second last talk, everyone. And then the final talk is by Adam H. on exceptional programming. Adam, are you around? Yep, come towards the front so you can get here nice and quickly. Da-da-da-da. So where are we? Well, we had the Undersea Kingdom. Like, let's rate all the jokes now. Undersea Kingdom. Like, is that your favorite? Clap if it's your favorite, the Undersea Kingdom. All right. Clap if the Extractor fan was your favorite. And clap if the Tina Turner What's Love Got to Do With It was your favorite. That's my favorite. Okay. But like, all right, so you guys preferred the longest one with the really bad pun at the end. So I'm just using that to like mentally, calibrate what I should do for you next time. All right, yep. I think we can manage this. I know one about a man with an orange for a head. That's quite special. There you go.
I need one more second, please, because...
How did everyone enjoy the social evening yesterday? Like, clapping slightly muted there by the people who are still hungover going, well, I enjoyed it, but I regret it. I got there at about midnight, and there was no food, so all I had to eat for the first few snacks was nothing but like chocolate eclairs and cream cakes, and I had about 6 of them. And then suddenly they did bring loads more actual food out, and I felt that was a bit of a waste to have my starter be entirely cake. Oh my God, is there going to be audio in this demo as well?
There will be a live demo, I hope. So I would like to talk about my dream when I was young. My name is Wojciech Kędzierski, and I always wanted to fly. I always wanted to be a pilot. I'm not sure if this dream will be fulfilled, but I found another alternative to the ways of flying. So lately, there is this huge topic like drones, self-flying unmanned vehicles. So the plan of this talk is presented here. Basically, I think that each lightning talk should have 3 main threads, like getting attention, inspire, and spread awareness. In my case, I would like to get an attention by having a live demo. And yes, I will fly a quadcopter. I would like to, however, also present the fun part of flying a drone, obviously. I'm going to skip the technical lesson because we have just 5 minutes, obviously. And what's more important is the awareness about this technology. It's currently banned in Spain. You cannot fly outside because it's a danger for other people and flying vehicles. I don't think this drone will go outside, and I don't think it's a risk for property or other people like getting hurt. That's why I was reading this legislation, but it's difficult for me to read in Spanish, so I assume it's legal. However, I consider myself to dream a lot and think about what might go wrong, and that's what I would like to present. So I'm going to fly this drone, which is not what you expect. Let's hope it will fly. It can actually flip. Here it is. So here is one part of the live demo. The real reason is that lately I've been also producing my own drone. And from my friend, I received a question when I was showing off, by the way, I have created my own, I built my DIY drone. And the first question was, does it fly? So here it is the drone I have produced on my own. So this is for my friend, dedication. I'm not sure the camera will register that, but so that was the second part of my interactive demo. So yes, Amory, it flies. What might go wrong if you... Why did I do this demo outside? So it turns out that you can really hurt somebody. If you didn't fly the drone your own, you're not aware, because obviously most of us play video games. You might think it's very easy, and it is if you already have the experience. So I'm not going to let you fly this drone, and I highly do not recommend flying it, but we can talk about this small one after this talk, and that was the purpose of this meeting. So it's really important to think about the fact that you can hurt somebody and damage a property that you wouldn't expect you can damage, like a flying vehicle or even a car driving in the road. The drone can fall from the sky when the battery falls unexpectedly. So why wouldn't I fall over your heads here if I already know I can fly this drone? So I estimated the risk is not bearable, and somebody can get hurt because if it falls, and the quadcopter might get broken, but this is just a few dollars. And this is another thing I would like to stress. This technology is getting extremely cheap, and you wouldn't believe that this small drone I was flying at the beginning of this presentation is around 20 bucks, and you can get it, and I'm not going to advertise where and what is the brand. I will just skip it. But it's definitely and most of the people can afford it. I highly recommend. It's a great exercise for your brain. And how does it relate to Python and this conference? So I think that I fly with Python. I work at Applause. And the reason I'm talking about Applause is that we are hiring great engineers that are not only focused on one technology, and they are not focused only on Python, but they can actually do stuff around the world. So I would like to thank you for the presentation. I'm really happy that nothing got broken or nobody got hurt. So thank you.
All right, our last talk is from Adam. Yeah. An apposite pachyderm, everyone. Irrelevant. That way you've learned 3 things from that joke. The word apposite, which means in the correct place or appropriate. The word pachyderm, which means thick-skinned in Greek. So that includes elephants and rhinoceroses is I. And then you've got a joke out of it as well. What do you call an apposite pachyderm? Irrelevant. I liked it. There you go. Yeah, really long stories. Man with an orange for a head. What else do we have? So it's coming up. This is the last talk. It's 6:30. Are there any announcement from the organizers? Have we got any organizers here? Anything we should know about tomorrow? Or anything we've got to get done? All right, I'm still wearing my beginner mentor badge, anyone? So any questions at this point? What's with the stars? What's with the stars? Well, the stars were from this. This is the kind of thing you pick up if you hang around the Django Girls booth for more than about 5 minutes. So they gave me a present. It was really nice. It was a goat. So I thought I'd wear the stars just to represent that. There you go. Stars and mouses. Yeah, good question. Thank you. I was happy to answer it. Any others? There you go. They're flip-flops. You know, you can't really wander around freely in flip-flops. Like, this keeps me more grounded. Definitely recommend it for talks. Like, because if you're with flip-flops, you're like, and you need to go somewhere, you know, you've got this sort of like, oh, maybe I'll trip over them slightly, and I feel like it's not quite right. And whereas if you've got no shoes, you know everything. You're in contact with the ground. You're safe. Like, from the ground up, everything's all right. So hopefully the presentation is going to go well as well. Like, little details there. Who here read my tips for, like, who here is a speaker? Just keep
who
your hands
knows
up.
Xrandr?
Yeah, who here is like an Xrandr contributor that would like to come and help?
Huh? No. Oh, screw it. Let's just do like this. This works.
That looks pretty good. You ready?
Yeah, I'm
Take
ready.
it away.
Yeah, so in Python, we have all these very, very, very contrived things like program flow components like ifs and returns and raise. But in C, those guys only ever use return for returning an error code. So we think this is a very contrived way of doing things. So me and my colleagues sat in the sauna the other day and discussed this problem and came up with a very good solution, which we call exceptional programming. So the solution is this. We do like the C guys, but in reverse, and replace everything with exceptions. So this is obviously a very good method, because we don't return here. We don't do any sort of weirdness. We just races. And we can show this off right here. This obviously prints a 1. Exactly like you would expect, or not. Can also show this is obviously a very bad method where you use weirdness like returns. So let's show off what this results in. So we have not only implemented this on methods, but on comparative things as well. So obviously, you don't want to use ifs if you can choose to use exceptions instead. So this is a fizz buzzer written purely in exceptional state flow.
Whoa.
And since and everyone who knows what FizzBuzz is knows that this means that in the no exception error is basically equivalent to none in this case. Because if you don't raise anything, this is what will get raised. So the FizzBuzz is obviously working as said. And this is all uploaded on GitHub. You can use it if you want to. I don't recommend it.
All right. Thanks very much. So that takes us to the end of the lightning talks. Thanks very much to each and every one of you for being absolutely wonderful. I must have spoken to about 100 people at this conference. Every single one of them is amazing, lovely, wonderful people, completely different from each other in odd and weird ways. And so thank you all for being exceptional. Thank you for being here. One more day of the conference. Give yourselves a big round of applause to yourselves, all the speakers, all the organizers, everyone. Have a lovely evening. Good night. Just to me.